Welcome to a journey across the world's oceans, where we'll explore 100 true maritime mysteries and unsettling facts. Let the rhythm of these tales carry you gently towards sleep, as we venture into the deep waters where reality becomes stranger than fiction. Our first story takes us to the coast of Mauritania, where something extraordinary and eerie awaits. There, along a desolate stretch of shoreline near Nouadhibou, lies the world's largest ship graveyard. Over 300 vessels rest in the shallow waters, their rusted hulls protruding from the waves like the rib cages of ancient beasts. These aren't pleasure craft or small fishing boats. These are massive cargo ships, trawlers, and ocean-going vessels, each one abandoned deliberately. In the 1980s, as fishing regulations tightened and chuan maintenance became costly, ship owners discovered it was cheaper to simply beach their vessels and walk away. So they sailed their ships to this remote bay one final time, ran them aground, and left them to the mercy of the salt and sand. What makes this place particularly haunting is the silence. Imagine standing on that beach at twilight, surrounded by these metal giants slowly decomposing, their empty bridges and holds creating an orchestra of creaks and groans as the tide moves through them. The locals say that on foggy mornings you can hear the ships settling, metal grinding against metal, as if they're trying to pull themselves back out to sea. As we drift further into the ocean, let me tell you about something that happens in waters around the world, something that has terrified sailors for centuries. It's called bioluminescent blooms, but to those who've witnessed it unprepared, it seems like something from another world entirely. Picture this. You're sailing at night across a dark ocean. The moon is hidden behind clouds. Suddenly, the water around your vessel begins to glow. Not just a faint shimmer, but an intense, otherworldly blue-green light that pulses and swirls with every movement of your ship. The wake behind you blazes with luminescence. If you put your hand in the water, it comes out dripping with what looks like liquid light. This phenomenon is caused by billions of tiny organisms called dinoflagellates, which emit light when disturbed. But here's what makes it unsettling. In certain conditions, particularly in the Indian Ocean and off the coast of Somalia, these blooms can be so massive and so bright that they're visible from space. Entire sections of ocean, hundreds of miles across, glowing in the darkness. Ancient sailors, seeing this for the first time, believed they had sailed into the realm of sea gods or entered the underworld. Even today, with our scientific understanding, there's something deeply unnerving about the ocean spontaneously illuminating beneath you, as if something vast and alive has noticed your presence. Let's descend now, down into the depths themselves. Here's a fact that's both fascinating and deeply unsettling. For every 33 feet you descend into the ocean, the pressure increases by 1 atmosphere. At the deepest point in the ocean, the Mariana Trench, the pressure is over 1,000 times what we experience at sea level. What does this mean in practical terms? It means that at those depths, the pressure would crush a human body instantly. But here's where it becomes truly strange. Life exists there. Creatures have evolved to live in conditions that would obliterate us in milliseconds. In 1960, when Jacques Picard and Don Walsh descended to the bottom of the Mariana Trench in the Bathyscaphe Trieste, they expected to find nothing but empty, lifeless mud. Instead, through their small viewport, they saw something move. A flatfish, they believed, swimming along the bottom at a depth of nearly 7 miles below the surface, where the pressure is equivalent to having 50 jumbo jets stacked on top of you. Think about that as you drift towards sleep. There are creatures living in places so hostile, so utterly alien, that we could never survive there even in our strongest submarines. And yet they glide through that crushing darkness as easily as we walk through air, in a world that exists right here on our planet, yet remains more foreign to us than the surface of Mars. Our next story concerns something that happens more often than you might think, though you rarely hear about it. Every year, ships vanish, not in dramatic storms or battles, but simply disappear. The oceans are vast, covering over 70% of Earth's surface, and shipping lanes are like narrow threads stretched across an immense fabric. When a ship deviates from its route or fails to report in, it can take days or even weeks before anyone realizes something is wrong. And by then, the ocean has had time to swallow all evidence. Consider the MV Joyita, discovered adrift in 1955 in the South Pacific. The ship was found partially submerged but still afloat, with no one aboard. The engine was stopped, the radio was tuned to the distress frequency but never used, and personal belongings were scattered about as if the crew had left in a hurry. 25 people had simply vanished. The life rafts were gone, but they were never found. No bodies ever surfaced. The investigation concluded that the crew had abandoned ship, but no one could explain why they would leave a vessel that was still seaworthy, or where they could have gone in the middle of the Pacific Ocean. This wasn't an isolated incident. It's part of a pattern that continues today. Ships leave port, sail into the vast blue, and sometimes they just stop existing. The ocean keeps their secrets. As we continue our journey through maritime mysteries, let me share something that scientists only recently discovered, and it's changed how we understand the ocean entirely. In the early 2000s, researchers began finding enormous structures on the ocean floor, circular formations up to 6 miles across. They weren't natural geological features. They were made of fishing nets, hundreds of thousands of tons of abandoned fishing gear, tangled together over decades into massive, slowly rotating gyres of netting that trap and kill marine life continuously. These structures, known as ghost gear, operate like enormous, patient predators. A net catches a fish. The fish attracts a larger predator, which also becomes entangled. That creature attracts scavengers, which themselves become trapped. The cycle continues indefinitely, these underwater webs claiming victims year after year, decade after decade. The truly unsettling part is that we don't know where all of them are. They exist in the deep ocean, beyond the reach of casual observation, some of them still catching and killing in waters that haven't seen a fishing vessel in 50 years. Imagine diving in the open ocean and suddenly encountering a wall of netting stretching away into the murky distance in all directions, decorated with the skeletons of everything that tried to pass through. Our next story takes us to a specific location that sailors have whispered about for generations. In certain parts of the ocean, usually far from land, ships' crews report entering areas of absolute silence. It's not just the absence of human-made sound. In these zones, the usual noises of the sea cease entirely. No waves breaking, no wind whistling through the rigging, no creaking of the hull. Crew members report that even dropping a metal tool on the deck produces a muted, dead sound, as if the air itself has become thick and resistant. These zones don't last long, sometimes just a few minutes, but the psychological effect on crews is profound. Sailors describe feeling watched, or feeling as though they're moving through something rather than across water. Some report that compasses behave erratically during these periods, though instruments show no other anomalies. Scientists have theorized these might be caused by unusual atmospheric conditions, or underwater topography that dampens sound. But no one has successfully documented the phenomenon under controlled conditions. It remains an experience passed down through maritime communities, a shared knowledge that something out there occasionally transforms patches of ocean into something that feels fundamentally wrong. Let me tell you about something that exists right now, this very moment, as you listen to this. There are ships at sea carrying cargo that no country wants to claim, and no port will accept. Some of these vessels have been sailing in circles for years, burning through fuel, paying their crews to maintain a ship that will never dock again. They carry waste, chemicals that are illegal to dispose of on land, or materials that have become politically impossible to deliver. Their owners have gone bankrupt or disappeared, but the crews remain, trapped in a kind of maritime purgatory. One such ship, the MV Aman, spent over a year anchored off the coast of Egypt, its crew unpaid and unable to leave, guarding a cargo of oil that had no buyer. When interviewed by journalists who chartered a boat to reach them, the crew described the psychological toll of living on a ship with no purpose, floating in sight of land they couldn't reach, maintaining a vessel that would never complete its journey. There are dozens of these ships scattered across the world's oceans right now, floating warehouses full of substances we can't get rid of, crewed by men and women who can't leave, drifting in the spaces between nations, where responsibility dissolves like salt in water. Our next story brings us full circle, back to the most unsettling truth about the ocean: how little we truly see of what happens there. Maritime law requires ships to maintain a constant watch, someone always alert on the bridge scanning the horizon. But here's what they're not scanning for: all the things that happen below the surface, in the 9/10 of the ocean that remains hidden from view. Consider the largest animal to ever exist on Earth, the blue whale, which can weigh over 200 tons. These creatures move through the ocean largely unseen. You could spend your entire life on the water and never see one, even though they pass beneath ships daily. If the largest animal ever to live is essentially invisible to us, what else are we missing? Submarines routinely detect sounds in the deep ocean that don't match any known source. The bloop, recorded in 1997, was detected by sensors 5,000 kilometers apart and was louder than any known biological or geological sound. Its origin remains unexplained, and that's just one example among hundreds of unidentified acoustic events recorded in the deep. As you drift towards sleep, consider this. The ocean covers 200 million square miles of our planet. We've explored less than 5% of it. Everything we've discussed tonight, all these mysteries and unsettling facts, come from that tiny fraction we've managed to observe. The remaining 95% waits in silence and darkness, keeping its secrets. Let's talk about something the ocean does that defies our everyday understanding of the world. The ocean is layered, not just in temperature or salinity, but in time itself. When something sinks in the ocean, it doesn't simply fall to the bottom. It descends through distinct layers, each with its own ecosystem, its own rules. First, there's the sunlight zone, where colors exist and photosynthesis still happens. Then comes the twilight zone, where the last rays of light fade into perpetual dusk. Below that, the midnight zone, where darkness is absolute and has been for millions of years. But here's what makes this eerie. These layers preserve things differently. A whale carcass sinking through the ocean creates what scientists call a whale fall, and it can sustain a unique ecosystem for decades. In the deep layers, where temperatures hover just above freezing and no oxygen reaches, decomposition happens so slowly that researchers have found shipwrecks from the 1800s with ropes still intact, wood that looks freshly cut, and even food stores that appear almost edible. In 2001, divers exploring a Roman shipwreck found amphoras sealed with wax, still containing olive oil and wine from 2,000 years ago. The oil was still liquid. The wine had turned to something else, but it was still there, suspended in time by the cold, dark pressure. Think about that. There are layers of the ocean where time moves differently, where the past is preserved in a state of slow suspension, waiting in the darkness. Let me tell you about the SOFAR channel, the sound fixing and ranging channel, a layer of the ocean that exists around 3,000 feet down where sound behaves in impossible ways. Due to the specific temperature and pressure at this depth, sound waves don't dissipate normally. Instead, they bend and refract, traveling horizontally for thousands of miles without losing strength. A whale singing in the SOFAR Channel off the coast of Australia can be heard by another whale near Antarctica, over 6,000 miles away. During the Cold War, the US Navy established a network of underwater microphones tuned to this channel, hoping to detect enemy submarines. What they heard instead was far stranger. They detected sounds they couldn't explain, metallic groans, rhythmic pulses, and something they called bioduck, a mechanical-sounding quack that repeated in patterns for hours at a time. It took decades to identify it as coming from Antarctic minke whales. But here's the unsettling part. There are still sounds in the SOFAR channel that have no known source. The Julia sound, recorded in 1999, was so loud it was detected across the entire equatorial Pacific. It lasted for about 15 seconds, rose and fell in frequency, and sounded almost like a living thing calling out. Some scientists believe it was an iceberg scraping across the ocean floor. Others aren't so sure. Right now, as you listen to this, sounds are traveling through that channel, crossing entire oceans in the deep, dark layer where sound lives forever. Some of them we put there. Some of them we can't explain at all. Our next story takes us to something beautiful that becomes deeply unsettling when you understand what it means. Off the coasts of California, Norway, and Tasmania grow vast underwater forests of kelp, some of the stalks reaching over 100 feet tall, swaying in the current like trees in the wind. Divers describe swimming through these forests as surreal, almost dreamlike. The kelp filters the sunlight into shifting patterns of green and gold. Fish move through the fronds like birds through branches. It's one of the most beautiful places on Earth. But kelp forests can disappear almost overnight. When water temperatures rise even a few degrees, or when sea urchin populations explode, entire forests can be reduced to bare rock in a matter of weeks. And here's what makes it eerie. The kelp doesn't just die and float away. The holdfasts, the root-like structures that anchor the kelp to rocks, remain. Fields of these empty holdfasts cover the ocean floor like a burned forest. All the anchors still in place, but nothing growing from them anymore. Divers who knew these forests before they vanished describe returning to find the landscape utterly transformed. Miles of what was once lush, living cathedral turned into an underwater wasteland. The holdfasts remain as markers, thousands upon thousands of them, like gravestones in a cemetery that stretches beyond sight. And sometimes, for reasons we don't fully understand, the forests return. New growth springs from the old holdfasts, and within months, the forest stands again. The ocean has a way of erasing its own history, then rewriting it over and over. Let me tell you about drift nets, but not the ones you're thinking of. I'm talking about the ones that were lost or abandoned decades ago, and they're still out there, still fishing. In the 1970s and 80s, industrial fishing fleets used drift nets that stretch for 30, 40, sometimes 50 miles. These walls of death caught everything in their path. When international law banned them in the 1990s, many were simply cut loose and left in the ocean. These nets are made of synthetic materials that don't biodegrade. They drift with the currents, spanning vast distances over the years. They get weighted down with their catch, sink to the mid-depths, and then, as the trapped creatures decompose, they rise again and continue fishing. Researchers estimate there are thousands of miles of these ghost nets still circulating in the Pacific Ocean, following the gyres, passing through the same waters year after year in slow, predictable patterns. They're invisible from the surface, and by the time a boat spots one, it's often too late to avoid it. In 2014, A sailboat crossing the Pacific hit something that stopped them dead in the water. When divers went down to investigate, they found a drift net wrapped around the keel that stretched back into the murky water as far as they could see. It took them 6 hours to cut through it. When they finally broke free and motored away, they looked back and saw the net rising to the surface briefly, before sinking again, continuing its endless journey through the ocean. Now let's talk about something that affects every person who spends extended time at sea, but is rarely discussed: the psychological phenomenon known as sea madness or maritime psychosis. It starts subtly. After weeks or months at sea, with the same horizon in every direction, the same routine every day, the mind begins to play tricks. Sailors report seeing land where there is none, seeing ships that vanish when approached, hearing voices in the wind and waves. The most documented cases come from solo sailors crossing oceans alone. Many keep detailed logs of their experiences, and these logs reveal a pattern. Around the 3rd or 4th week of solitude, most solo sailors report sensing a presence aboard their vessel. Not something threatening usually, but someone or something that feels like it's watching, or occasionally helping. Joshua Slocum, the first person to sail solo around the world, wrote in his log about a phantom companion who appeared during a storm and helped him navigate. He described the figure in detail: the clothing, the bearing, even conversations they had. When he reached port, he spoke of this companion as if the experience had been entirely real. More recently, sailors with satellite communications have called in during their crossings to report similar experiences. They know it's not real. They can explain the psychology of isolation and sensory deprivation. But in the moment, alone on a small boat in the middle of an ocean, surrounded by water to every horizon, the presence feels undeniably real. The ocean, it seems, doesn't let you be truly alone. It fills the void with something, whether you want it to or not. Let's talk about submarines, specifically about what happens when they sink. Unlike surface ships, which may float for hours or even days after damage, a submarine that loses integrity descends quickly, pulled down by the weight of its hull. The crews know exactly what's happening. Modern submarines have depth gauges that show them passing each threshold: test depth, crush depth, and beyond. At a certain point, the pressure exceeds what the hull was designed to withstand. What happens next takes less than a second. The submarine implodes. The air inside, compressed to a fraction of its volume, heats to thousands of degrees in an instant. Then, the ocean rushes in with the force of a bomb blast. Everything inside is destroyed so quickly that there's no time for awareness, no moment of realization, just existence, and then nothing. But here's what haunts salvage crews and naval investigators. Submarines rest on the ocean floor largely intact. When they're found, sometimes decades later, they look almost peaceful. The hull may be crumpled in places, but the vessel is recognizable. And inside, if they're ever recovered, everything is compressed, reduced, transformed by pressures we can barely comprehend. Several submarines have been lost in waters too deep for recovery. They remain down there, tombs in the deep trenches, slowly being covered by sediment. In 1,000,000 years, there'll be fossils, strange geometric shapes in the rock, evidence that something once built machines to explore the deep. Here's a fact that sounds simple but becomes increasingly strange the more you think about it. The ocean has a surface. There's a boundary, just a few molecules thick, between the water and the air. And that boundary is constantly breaking and reforming millions of times per second, everywhere across 200 million square miles of ocean. But it's not a simple boundary. This microscopically thin layer is where chemistry happens that we're only beginning to understand. Gases exchange between ocean and atmosphere here. Organic molecules concentrate in this layer, sometimes forming a kind of invisible skin on the water's surface. Bacteria thrive in this boundary zone, feeding on the concentrated nutrients. When you see pictures of the ocean from space, that blue surface you're looking at is really a thin film of organic compounds, bacteria, and chemical reactions stretched across the entire planet. It's so thin that if you dove through it, you wouldn't feel anything. But it's there, and it's alive. Here's what makes this unsettling. That boundary is where the ocean ends and the atmosphere begins, but it's also where they merge. Water evaporates through it, carrying salt and microorganisms into the air. You've probably breathed in ocean bacteria that were carried thousands of miles inland on the wind. The ocean doesn't stay in its boundaries. It extends up into the air, invisible, riding every breeze that crosses the water. When you breathe the air near the coast, you're breathing the ocean itself, molecule by molecule, particle by particle. The boundary isn't really a boundary at all. Let me tell you about something that happens every night in the ocean. A migration so massive it's been called the largest movement of animals on Earth. Yet most people have never heard of it. When the sun sets, creatures from the deep rise toward the surface. Billions upon billions of them, squid, fish, jellies, crustaceans, all moving upward through the water column to feed in the more productive surface waters under cover of darkness. Then, just before dawn, they descend again, sometimes traveling 3,000 feet or more, back to the safety of the deep. This is called vertical migration, and the sheer biomass involved is staggering. If you're on a boat at night and shine a light into the water, you'll see them. Thousands of eyes reflecting back, layers of creatures stacked from the surface down into the darkness below. But here's what makes it strange. Some of these creatures make this journey every single night of their lives, never stopping, always rising and falling with the sun. They spend half their lives in near-freezing darkness and half in the relatively warm surface waters, traveling distances equivalent to several miles every day, just to feed and hide, in an eternal rhythm. Researchers studying this migration have found creatures they can't identify, species that may be completely unknown, rising briefly to the surface each night before vanishing back into the deep. Some nights, the diversity of life in those rising columns includes animals from families of creatures we thought went extinct millions of years ago. Every night, an entire hidden ecosystem rises to meet the surface, feeds, and descends again before dawn. And we only discovered this was happening on such a massive scale in the last few decades. Our next story is about something mariners have known for centuries, but rarely discuss. The profound psychological weight of being truly far from land. There's a point in every ocean crossing where you pass beyond the range of rescue. If something goes catastrophically wrong, no helicopter can reach you, no ship can arrive in time. You're in what mariners call the void, where the only help available is what you brought with you and whatever other vessels happen to be nearby. In the middle of the Pacific Ocean, you can be over 1,000 miles from the nearest land in any direction. If you fell overboard at night, your vessel might not be able to find you again. The ocean is vast, you're small, and darkness hides everything. Search patterns might pass within 50 feet of you and never see you. People have been lost this way, sometimes within sight of their own ship, swallowed by the enormity of the sea. Modern sailors with satellite communication describe the strange psychological effect of knowing they can call for help, but also knowing that help is days away. It changes how you think about risk, about safety, about the fragility of the technology keeping you alive. One sailor described it like this: you're floating on a tiny platform of safety in an environment that would kill you in minutes without it. The only thing between you and death is a few inches of fiberglass and the competence of your crew, and below you, there's nothing but darkness going down for miles. But eventually, every voyage ends. land appears on the horizon, the void releases you, and you step ashore, back into a world where distance is measured in minutes, not days, and where help is always just a phone call away. As you settle deeper into rest, let me tell you about a phenomenon that has puzzled maritime authorities for decades. Ships that reappear long after they've been given up for lost. In 1948, a fishing vessel named the Aurang Medan sent out a distress call in the Strait of Malacca. The message was chilling. All officers, including captain, are dead lying in chart room and bridge, possibly whole crew dead. Then, after a brief pause, a final transmission. I die. When rescuers reached the ship, they found the entire crew dead, their faces frozen in expressions of terror, their bodies showing no signs of injury or struggle. Before they could investigate, the ship caught fire and sank. But here's what's strange. Decades later, researchers trying to verify the story found no record of a ship named Aurang Medan in any registry. No shipping company claimed ownership, no insurance was filed, no families reported missing crew members. It's as if the ship existed only for that one moment of distress, then vanished not just physically, but from all records, as though it had never been real at all. This pattern repeats throughout maritime history. Ships appear in distress, are encountered briefly, then disappear so completely that researchers later question whether they existed. The ocean, it seems, sometimes gives up its ghosts, but only for a moment, before taking them back into the deep. Let's talk about something you can see, but perhaps haven't thought about. The colour of the ocean changes as it gets deeper, and that change tells a story about light itself dying. Near the coast, water might appear green or brown, full of sediment and life. Further out, it becomes blue, that classic deep ocean blue. But this blue isn't a property of the water itself. It's what's left after the ocean has absorbed every other colour. Red light disappears first, within 15 feet of the surface. Orange follows, then yellow. By the time you're 100 feet down, the world is rendered in blues and greens only. At 200 feet, even green is gone. Beyond that, there's only a dim blue twilight, fading gradually into total darkness. This means that if you were to descend into the deep ocean, you would watch the world lose its colours one by one. A red fish at 100 feet down has no red colour to reflect, so it appears black. Blood looks green in the twilight zone, then black below that. The ocean doesn't just hide things in darkness, it erases them from the spectrum of visible light, removing their colours one wavelength at a time. And here's something that makes it even stranger. Some deep-sea creatures have evolved to produce their own red light, a colour that essentially doesn't exist at those depths. They use it like a personal flashlight that only they can see, illuminating prey in a colour that's invisible to everything else. They've claimed a portion of the spectrum that the ocean stole, using it for their own secret purposes in the darkness. Now let me tell you about something the ocean does that's both beautiful and unsettling. It breathes. Not metaphorically, but in a very real way that affects the entire planet. Phytoplankton, microscopic plants floating near the surface, produce about half of all the oxygen in Earth's atmosphere. Every other breath you take comes from the ocean, generated by organisms so small you'd need a microscope to see them individually. But here's what makes it eerie. This process is fragile and invisible. Phytoplankton populations can collapse rapidly due to temperature changes, pollution, or factors we don't fully understand. When they die off in large numbers, they create dead zones, areas of ocean where oxygen levels drop so low that nothing can survive. These dead zones are growing. There are now over 400 documented dead zones around the world, some of them thousands of square miles in size. In these areas, the ocean floor is covered with the bodies of creatures that couldn't escape fast enough. Crabs, fish, bottom-dwelling animals, all suffocated by the same water that once sustained them. And because this happens below the surface, we often don't know about these dead zones until they're well established. The ocean could be losing its ability to breathe, losing its ability to provide oxygen for the planet, and from the surface, everything would look exactly the same. The water would still be blue, the waves would still roll, and we wouldn't know anything had changed until we sent instruments down to measure what's happening in the depths. The ocean breathes, and we depend on that breath, but we can't see it happening, and we don't always know when it stops. Let's descend to the ocean floor now, to the abyssal plains that cover more of Earth's surface than all the continents combined. These plains are flat, featureless expanses of sediment that have been accumulating for millions of years. Here's what makes them remarkable. They're archives. Every piece of sediment that settles there tells a story. Microscopic shells from plankton that lived and died in the surface waters millions of years ago. Dust from volcanic eruptions, even particles from meteor strikes are all preserved in layers, slowly building up at a rate of about 1 centimetre per 1,000 years. Scientists who study these sediment cores can read the history of Earth's climate, ocean chemistry, even mass extinction events, all recorded in the mud of the deep ocean floor. It's like reading a book written in dust, thousands of feet thick, that spans hundreds of millions of years. But here's the unsettling part. That archive is constantly being erased. Ocean currents, rare and powerful, occasionally sweep across the abyssal plains, stirring up the sediment and scrambling the record. And in some places, the ocean floor itself is being recycled, pulled down into subduction zones, where tectonic plates meet, carrying its archive of deep time back into the Earth's mantle to be melted and reformed. Entire chapters of Earth's history have been lost this way, scraped off the ocean floor and dragged back into the planet's interior. We'll never know what those chapters contained, what events they recorded, because the ocean both preserves and destroys its own memory. Our next story takes us to the polar oceans, where something extraordinary happens that few people ever witness: the sound of ice forming. When seawater begins to freeze, it doesn't do so quietly. The process creates tiny air bubbles trapped in the ice, and as the ice forms, these bubbles release with a sound like high-pitched tinkling or ringing. When this happens across miles of ocean surface during the polar night, it creates an eerie chorus of crystalline notes echoing across the water. Sailors and researchers stationed in the Arctic and Antarctic describe this sound as otherworldly, like the ocean is singing as it transforms into ice. Some describe it as beautiful, others find it deeply unsettling. This reminder that the ocean is changing state around them, becoming solid, closing in. But there's another sound associated with polar ice that's even more unnerving: the sound of glaciers carving into the ocean. When a massive section of ice breaks away from a glacier, it doesn't just splash into the water. The sound it makes is like thunder, but deeper, more resonant. It can be heard for miles, a low rumble that you feel in your chest, as much as hear with your ears. And here's what makes it strange. These sounds are increasing. As global temperatures rise, more ice is breaking away, more often. The polar oceans are filled with these groans and crashes now, a constant background noise of ice returning to the sea. The ocean is accepting back what it once lost, and the sound of that acceptance echoes across the empty waters of the poles. Let me tell you about the ocean floor as a museum of human history, but not the kind of museum you can visit. Over the course of maritime history, an estimated 3 million shipwrecks rest on the ocean floor. 3 million. That's not an exaggeration. From ancient Roman merchant vessels to World War II battleships, from Viking longboats to modern cargo ships, they're down there, scattered across the abyssal plains and continental shelves. Each one is a time capsule. Some are scattered fields of debris, others are remarkably intact, preserved by the cold and pressure. And inside them, everything that was being carried when they sank. Trade goods, personal belongings, sometimes human remains, all suspended in time. But here's the unsettling reality. We've explored less than 1% of these wrecks. The rest remain where they fell, in darkness, unknown and unmapped. Some are in water too deep for any hope of exploration. Others are in waters so remote that no one has ever thought to look for them. There's a shipwreck from the 1600s somewhere in the Indian Ocean that, according to records, was carrying 50 tons of gold and silver. It's never been found. There are Roman ships that went down carrying statues and artifacts that would revolutionize our understanding of ancient art. We know approximately where they sank, but the ocean floor in those areas is so vast and the ships so small by comparison that searching for them would be like trying to find a specific grain of sand on a beach. The ocean floor is humanity's largest museum, and we'll never see most of what it contains. It keeps our history, preserves it, and refuses to give it back. Now let's talk about something that exists in the deep ocean that most people don't know about. Sleeper sharks, specifically the Greenland shark. These creatures live in the deep, cold waters of the Arctic and North Atlantic, moving slowly through the darkness at depths of up to 7,000 feet. They grow to over 20 feet long, but here's what makes them remarkable. They might be the longest living vertebrates on Earth. In 2016, researchers studying Greenland sharks determined that one individual was approximately 400 years old. 400 years. This shark was swimming in the ocean when Galileo was alive. It was already ancient when the United States was founded. It has lived through the entire modern age, slowly patrolling the deep Arctic waters. But here's what's eerie about these sharks. They move so slowly and live so deep that they're rarely seen. They're like ghosts drifting through the abyss. Most of them are blind, their eyes clouded by parasites that attach when the sharks are young and remain for life. They navigate by smell and pressure sensors, moving through a world of total darkness that they've never seen. And they're everywhere in the deep Arctic. Researchers estimate there could be millions of them, living their centuries-long lives in the cold and the dark, eating whatever falls from above or whatever else they encounter in their slow wanderings through the depths. Think about that. Right now, there are creatures swimming in the Arctic that have been alive since before most of human history was recorded, blind and patient, drifting through darkness that has never known light. Let me tell you about something that happened in 1992 that revealed just how connected the world's oceans truly are. A cargo ship crossing the Pacific encountered a storm. One of its containers broke loose and fell overboard. Inside that container were 28,000 rubber ducks, along with other bath toys, all destined for American stores. The container broke open, and suddenly, 28,000 rubber ducks were adrift in the middle of the Pacific Ocean. Oceanographers seized on this as an opportunity. They began tracking where these ducks appeared, using reports from beachcombers and sailors who found them. What they discovered mapped out ocean currents with remarkable precision. Some ducks reached Alaska within months. Others took years to reach the coast of Australia. Some ended up frozen in Arctic ice, only to be released years later and continue their journey. Some traveled down to Antarctica. 15 years after the spill, rubber ducks were still washing up on beaches around the world. But here's what's unsettling. This means that anything that enters the ocean at one point can eventually reach almost anywhere else. Pollution, debris, plastic waste, all of it circulates through the global ocean in patterns we're only beginning to understand. Those rubber ducks traced paths that are followed by everything else we've lost or discarded in the sea. The ocean is one continuous body of water, and everything in it is traveling, slowly but constantly, following currents that connect every coast to every other coast. Nothing stays where it enters. Nothing is truly lost. It's all just traveling, endlessly circulating through the deep. Our next story is about something simple but profound: darkness. The ocean is dark, not just at night, but most of it, all the time. Below about 3,000 feet, no sunlight has ever reached. Not today, not yesterday, not in all of Earth's history has a single photon of sunlight touched those depths. This darkness is absolute in a way that's hard to comprehend. It's not the darkness of a room at night, where your eyes adjust and you can make out shapes. It's not the darkness of a cave, where a light source reveals walls and boundaries. It's the darkness of infinite space, empty and complete. And yet, it's full of life. Creatures have evolved in this permanent midnight, developing ways to sense and hunt and mate without ever experiencing light as we know it. Some create their own light through bioluminescence, brief flashes and glows that serve as signals in the dark. But most of the deep ocean is populated by creatures that have never seen anything, that navigate by pressure, smell, electrical fields, by senses we don't have and can barely imagine. Here's the thought to carry into sleep. Most of Earth's biosphere exists in permanent darkness. Most of the living space on our planet has never known light. And in that darkness, life doesn't just survive, it thrives, in forms and ways we're only beginning to discover. The deep ocean is dark and patient and full of slow, strange life that has been there since long before humans ever looked upon the sea. And it will be there long after we're gone, unchanged, waiting in the darkness as it always has. Rest now. Let the rhythm of these stories carry you deeper into sleep. There are 74 more tales still to come. But for this moment, let yourself sink peacefully into the darkness, like sediment drifting down through still water, settling gently on the ocean floor of dreams. As you drift deeper into rest, let me tell you about something that happened in the ocean long before humans ever sailed upon it. Something that still echoes through the water today. Around 55 million years ago, something catastrophic occurred. The ocean's temperature rose by about 5 to 8 degrees Celsius over just a few thousand years, an instant in geological time. This event is called the Paleocene-Eocene thermal maximum, and it fundamentally changed life in the sea. The warming caused massive die-offs of deep-sea creatures. But here's what's particularly eerie. We can see evidence of this event in the sediment cores from the ocean floor. There's a distinct layer, just a few centimeters thick, where the types of microscopic shells suddenly change completely. Below that layer, one set of species. Above it, entirely different ones. That thin band represents the death of one ocean ecosystem and the birth of another. And it's happening again, now, in our time. The ocean is warming, and we're beginning to see similar shifts in the sediment record being laid down today. Millions of years from now, if anything is here to study these layers, they'll see another thin band marking our era. Another moment when the ocean's blood grew too warm and life had to adapt or die. The ocean remembers everything, written in layers of mud and the tiny shells of creatures most people have never heard of. And what it's writing now is a story of change, happening faster than almost anything in the geological record. Now let me tell you about something flowing through the ocean that most people don't know exists: underwater rivers. These aren't metaphorical currents. They're actual rivers of dense, salty water flowing along the ocean floor, with banks and channels moving through the sea like rivers move through land. The largest of these is in the Black Sea, discovered only in 2010. It flows along the bottom with such force that if it were on land, it would be the world's 6th largest river. These underwater rivers are created when particularly salty or cold water becomes denser than the surrounding ocean and sinks, then flows downhill along the ocean floor. They carry sediment, nutrients, and even creatures along with them. Some of them have been flowing for thousands of years, carving channels in the ocean floor just like rivers carve valleys on land. But here's what makes them unsettling. We don't know where most of them are. The ocean is vast, and these rivers flow in darkness, unmapped and largely unexplored. Submarines have occasionally encountered them, feeling the current push them off course as they pass through layers of water moving in different directions. Imagine being in a submarine, descending through still water, when suddenly you feel your vessel being pushed sideways by an invisible current flowing through the depths. You're in a river you can't see, in the middle of the ocean, miles from land, being carried by a flow that has no surface and no obvious beginning or end. The ocean has geography we've barely begun to understand. Invisible landscapes of flowing water within water, moving through the deep in patterns we're only starting to map. Let me tell you about whale falls, but in more detail than before, because the story of what happens after a whale dies is both beautiful and deeply strange. When a whale dies and sinks to the ocean floor, it brings with it decades of accumulated energy from the surface. A single whale carcass can support a unique ecosystem for 50 to 100 years, going through distinct stages as different creatures colonize it. First come the scavengers. Sharks, hagfish, crabs, anything mobile enough to find the carcass and strong enough to tear through the tough skin. They strip away the soft tissue in a feeding frenzy that can last months. What remains is bones, still rich with lipids and nutrients. Then come the bone worms, osedacs. Strange creatures that look like animated flowers but are actually worms that root themselves into the bones and digest the fats locked inside. They have no mouth, no stomach, instead hosting bacteria inside their bodies that break down the oils in the whale bones. They can cover an entire skeleton in a garden of pink and red plumes, slowly consuming the bones from within. Finally, after decades, when even the bones are depleted, a community of bacteria moves in, feeding on the last chemical remnants of the whale. This stage can last for decades more, a thin film of microbial life on the scattered remnants of skeleton. But here's what's eerie. These whale fall communities are so specialized that some species are found nowhere else. They live only on whale bones in the deep sea, and they must somehow find new carcasses to colonize before their current home is completely consumed. How they do this, how they sense or locate a new whale fall in the vastness of the ocean, remains a mystery. The deep ocean floor is dotted with these gardens of bones, each one a small oasis of life in the desert of the abyss, quietly flourishing in the darkness, unknown and unseen. Now, let's talk about something that naval sonar operators discovered during the Cold War, something that still puzzles researchers today: the deep scattering layer. During World War II, naval sonar detected what appeared to be a false seafloor, a layer that reflected sonar signals back from about 1,000 to 1,500 feet deep. But this layer did something impossible. It moved. During the day, it stayed deep. At night, it rose toward the surface. Eventually, researchers realized this wasn't a physical layer at all. It was biomass, vast concentrations of fish, squid, and other creatures performing the vertical migration we discussed earlier. The sheer density of life was enough to reflect sonar as if it were solid ground. But here's what's strange. In some areas of the ocean, particularly in the Central Pacific, sonar operators report periods of complete silence. The deep scattering layer vanishes. The usual background noise of the ocean, the clicks and calls and movements of marine life, all of it stops. For hours, sometimes days, the ocean becomes acoustically dead, as if everything living in the water has simply disappeared. Then, just as mysteriously, it returns. The deep scattering layer reappears on sonar, the biological sounds resume, and the ocean is alive again. No one knows why this happens. Some theorize it's related to breeding cycles or feeding patterns, but the silence is too complete, too sudden. It's as if the ocean itself occasionally holds its breath. And in those moments, the deep becomes truly empty, truly silent in a way that's difficult to explain. Let me tell you about something the ocean does that seems almost impossible. It remembers temperature. Deep ocean currents are driven by differences in temperature and salinity. Water that sinks in the polar regions, cold and heavy with salt, flows along the ocean floor toward the equator. But these currents move slowly, incredibly slowly. The water that's currently reaching the equator along the ocean floor in the Atlantic began its journey in the Arctic over 1,000 years ago. This means the deep ocean is filled with water that last saw the surface during the Middle Ages. That water carries with it the temperature signature of a climate that no longer exists. It's a record, flowing slowly through the depths, of what the polar regions were like a millennium ago. And here's what makes it profound. We're changing the temperature of the surface ocean now, faster than at almost any time in Earth's history. The water sinking today in the Arctic carries a new temperature signature. 1,000 years from now, that warmer water will be reaching the deep equatorial ocean, carrying with it the thermal memory of our era. The ocean remembers, not in layers of sediment this time, but in the water itself, flowing in slow motion through the deep, carrying the past toward the future at a pace measured in centuries. What we do to the ocean today won't fully manifest in the deep circulation for hundreds of years. We're sending messages to the future, written in temperature, that won't be received for generations. Now let's talk about something that enters the ocean from outside our atmosphere: micrometeorites. Every day, about 100 tons of material from space falls to Earth. Most of it burns up in the atmosphere, but the smallest particles, dust-sized grains, drift down intact. And since the ocean covers 70% of Earth's surface, most of these micrometeorites end up in the sea. They settle through the water column, taking weeks or months to reach the ocean floor, where they become part of the sediment. And they're everywhere. If you scooped up a handful of abyssal sediment and examined it under a microscope, you'd find tiny spheres of melted rock, particles of iron and nickel, remnants of asteroids that spent billions of years traveling through space before ending their journey on the ocean floor. But here's what's remarkable. Some of these particles contain organic compounds, carbon-based molecules that could be the building blocks of life. They've been raining down on the ocean since before life began on Earth, possibly even helping to seed the primordial seas with the chemistry needed for life to start. The ocean is constantly receiving visitors from space, tiny ambassadors from the cosmos settling silently into the deep. Most people walk along the beach, swim in the waves, sail across the surface, never knowing that space dust is falling all around them, sinking down to join the archive of the abyss. We think of the ocean as separate from the universe beyond our planet, but it's not. Space is falling into it, grain by grain, every moment of every day. Let me tell you about tides, but not the simple explanation you learned in school. The reality of how tides work is far stranger. Yes, the moon's gravity pulls on the ocean, creating bulges of water on the sides of Earth closest to and farthest from the moon. But the ocean doesn't respond instantly or uniformly. Because of the shape of coastlines, the depth of water, and the Coriolis effect from Earth's rotation, tides behave in complex, sometimes bizarre ways. In some places, like the Bay of Fundy in Canada, tides can rise and fall over 50 feet twice a day. In other locations, like parts of the Gulf of Mexico, tides are almost unnoticeable. There are places where the tide comes in not as a gradual rise, but as a single wave called a tidal bore, rushing up rivers with enough force to carry boats along with it. But here's what's eerie. Tides are perfectly predictable. We can calculate the exact height of the tide at any location for any moment in the future with remarkable precision. The ocean, despite its chaos and mystery, follows clockwork patterns when it comes to tides. This means that 1,000 years from now, if anyone is here to observe it, the tide at any given location will arrive at almost exactly the time we predict today. The ocean's surface rises and falls like breathing, regular and eternal, driven by the dance of Earth and Moon, a rhythm that has continued for billions of years and will continue for billions more. In a universe of uncertainty, the tides are a promise, regular, reliable, eternal. The ocean keeps time with the heavens, and it always has. Now I need to tell you about something that's changing the ocean in ways we're only beginning to understand: plastic. Since we began mass-producing plastic in the 1950s, an estimated 8 million tons of plastic have entered the ocean every year. Much of it breaks down into smaller and smaller pieces, but it doesn't truly degrade. It just becomes microplastic, particles so small they're invisible to the naked eye but present in staggering quantities. Recent studies have found microplastics everywhere researchers look. In the deepest trenches, in Arctic ice, in the stomachs of creatures living miles below the surface. There are now areas of the ocean where the concentration of plastic particles exceeds the concentration of plankton. But here's what's deeply unsettling. We don't fully understand what this is doing to marine life or to the ocean ecosystem. Fish are eating it, mistaking it for food. It's entering the food chain at every level. Some of it carries pollutants, concentrated toxins absorbed from the water and delivered to whatever creature consumes the plastic. And it's essentially permanent. Every piece of plastic that has ever entered the ocean is still there, somewhere, either as visible debris or broken into smaller fragments. We've fundamentally altered the composition of the ocean, adding a new element to the water itself, and we won't know the full consequences for generations. The ocean that exists today is not the same ocean that existed 100 years ago. It's a new thing, a hybrid of water and polymer, of ancient chemistry and modern waste. And we made it that way, accidentally, by treating the ocean as infinite when it was really just very large. Our next story is about something simple that becomes profound when you understand the scale: salt. The ocean contains about 50 quadrillion tons of salt. If you could somehow extract all of it and spread it evenly over Earth's land surface, it would create a layer over 500 feet thick. That's enough to bury a 40-story building on every continent. Where did all this salt come from? Rivers primarily carrying dissolved minerals from the land to the sea over billions of years. The water evaporates and rains back down on land, but the salt stays. The ocean is essentially a trap for every mineral that washes off the continents, accumulated over geological time. But here's what's strange. The ocean's saltiness doesn't increase. Despite rivers constantly adding more salt, the ocean's salinity stays relatively stable. This means something is removing salt at the same rate it's being added. Some of it gets buried in seafloor sediments. Some is removed by chemical reactions with volcanic rock at mid-ocean ridges. Some crystallizes out in shallow lagoons. The ocean is in balance, a dynamic equilibrium that has maintained itself for hundreds of millions of years. It's salty enough to fundamentally change the properties of water, to affect what can live in it, to make it conductive enough to generate currents through interaction with Earth's magnetic field, but not so salty that it becomes like the Dead Sea. This balance is one of the ocean's great unsung achievements, maintaining stable chemistry across billions of gallons of water, despite constant inputs and changes. It's self-regulating on a planetary scale, keeping itself within parameters that allow life to thrive. As you settle deeper into rest, let me tell you about the eyes that watch from the ocean's twilight zone. Eyes that have evolved in ways that seem almost impossible. Many deep-sea fish have developed enormous eyes, sometimes making up half the mass of their head. These eyes are designed to capture every available photon in the dim twilight between the surface and the true darkness below. Some species have tubular eyes that point upward, scanning for the silhouettes of prey against the faint light filtering down from above. But here's what's remarkable. Some creatures have evolved eyes that can see things we can't even imagine. The barrel-leaf fish has a transparent dome on its head, and its eyes can rotate inside this fluid-filled chamber, allowing it to look up through its own skull. The brown-snout spookfish has mirrors instead of lenses in its eyes, the only vertebrate known to use mirror-based optics. And then there are the creatures that have given up on eyes entirely. In the deepest parts of the ocean, where no light has ever reached, eyes are useless. So many species have evolved to be completely blind. But they're not helpless. They navigate using other senses we barely understand: electrical field detection, pressure sensing, chemical gradients in the water. Right now, in the twilight zone, there are millions of eyes looking upward, watching for the shadows of prey or predators above them. And below them, in the true darkness, there are millions more creatures moving through a world without sight, sensing their environment in ways that have no human equivalent. The ocean is filled with watchers, both seen and unseen, monitoring the water in every direction, at every depth. Let me tell you about something that exists on the ocean floor that holds secrets we may never fully understand. Manganese nodules. These are potato-sized lumps of metal ore scattered across the abyssal plains, particularly in the Pacific Ocean. They grow incredibly slowly, adding layers of metal extracted from seawater at a rate of about 1 millimeter per million years. Some of the nodules on the ocean floor today began forming before dinosaurs walked the earth. What makes them fascinating is that they grow in concentric layers, like tree rings, and each layer records the chemistry of the ocean at the time it formed. They're time capsules, archives of ocean conditions stretching back tens of millions of years. But here's what's unsettling. Mining companies are now preparing to harvest these nodules for the valuable metals they contain. When they do, they'll be erasing records that took millions of years to write. Each nodule destroyed is a library burned, a unique archive of Earth's history ground up and processed for cobalt and nickel. And we still don't fully understand what role these nodules play in the deep-sea ecosystem. Small creatures live on them and around them. They may be important to the chemical balance of the abyssal plains. We're preparing to remove them by the thousands of tons before we finish studying what they are and what they mean. The ocean floor is covered in libraries we can barely read, and we're about to begin erasing them for the metal they contain. Once they're gone, that history is lost forever, ground to powder and extracted, leaving the abyssal plains swept clean of records that took longer to form than humans have existed as a species. Now let's travel to the Antarctic, where the ocean does something extraordinary beneath the ice shelves. It sings. The Ross Ice Shelf, a floating platform of ice the size of France, vibrates constantly. Scientists discovered this by placing seismometers on the ice, and what they recorded was unexpected. The ice shelf produces a continuous tone, almost musical, created by wind blowing across snow dunes on the surface. These vibrations travel through the ice and into the water below. But that's not the only sound. The ice itself, as it grinds against the bedrock where it's grounded, as it flexes with tides, as it slowly flows toward the sea, produces groans and cracks and pops that echo through the water. Seals and whales in Antarctic waters navigate by these sounds, using the ice's voice as a landmark in the dark water beneath the shelf. Here's what's eerie. The ice's song is changing. As ice shelves thin and warm, the frequency and pattern of their vibrations shift. Scientists can hear the ice changing, can listen to it becoming less stable, its voice growing weaker and more fragmented. The ice is telling us what's happening to it. singing its own slow dissolution into the water below. In a way, the ice shelves are dying audibly, broadcasting their transformation into the ocean they're melting into. And beneath them, in the cold, Antarctic water, creatures that have lived their entire lives listening to the ice's constant song are hearing it change for the first time in thousands of years. Let me tell you about something that terrified early ocean explorers, the false bottom phenomenon. When sailors first began using weighted lines to measure ocean depth, they sometimes encountered something impossible. They would drop a weighted line, feel it hit bottom, and measure the depth. Then, later in the same area, they would drop the line again, and it would go much deeper before hitting bottom. Or it wouldn't hit bottom at all in the same length of line. Some sailors believed they had discovered underwater mountains that moved, or that the ocean floor itself was shifting. Charts from the 1700s and 1800s show abyssal depths that vary wildly in the same location, measurements that contradicted each other in ways that seemed to violate the laws of nature. Eventually, we understood what was happening. Dense layers of plankton, massive schools of fish, even fields of jellyfish could all stop a weighted line, creating the sensation of hitting bottom when the line was actually caught in a layer of biological mass suspended in the water column. The sailors weren't measuring the ocean floor at all. They were measuring the thickness of life in the ocean. But here's what's unsettling. This means that early sailors genuinely didn't know how deep the ocean was. They were traveling across water that might be hundreds of feet deep, or thousands, with no reliable way to tell the difference. Every depth measurement was suspect, potentially off by miles, measuring living layers instead of the true bottom. The ocean was even more mysterious then than it is now, full of false bottoms and phantom grounds, where the line would catch on something you couldn't see and couldn't understand, leaving you to guess what lay beneath. Now let me tell you about the ocean's largest and oldest feature, the Antarctic Circumpolar Current. This current flows around Antarctica, the only current that circles the globe uninterrupted by land. It's the largest ocean current in the world, moving more water than all the world's rivers combined, carrying 150 times more water than the Amazon. But here's what makes it remarkable. It's been flowing for approximately 30 million years since Antarctica separated from South America and opened the Drake Passage. For 30 million years, water has been circling Antarctica in the same direction, driven by the same winds, following the same path. This current acts as a barrier, isolating Antarctica and keeping warm water away from the continent. It's one reason Antarctica is covered in ice, while the Arctic, which has no such circular current protecting it, is relatively warmer. But the current is changing. It's speeding up, moving faster now than at any time in the past 1,000 years. Warmer water is beginning to penetrate the barrier, reaching the ice shelves that fringe Antarctica. The oldest continuous current on Earth, flowing for 30 million years, is losing its ability to protect the continent it encircles. Think about that as you drift towards sleep. Something that has existed longer than most species currently alive on Earth, a current that has shaped global climate for longer than humans have existed, is changing within our lifetime. The eternal storm is faltering, and what comes next, no one can say with certainty. Let me tell you about coral reefs, but not as beautiful underwater gardens. Instead, consider them as what they really are: the largest biological structures ever built on Earth. The Great Barrier Reef is over 1,300 miles long, visible from space, built by creatures so small that thousands of them could fit in your hand. These polyps, tiny animals related to jellyfish, extract calcium from seawater and deposit it as limestone, building their skeleton around themselves. When they die, new polyps build on top of the old skeletons, and slowly, over thousands of years, these accumulated skeletons become massive structures. Some reefs are over 50 million years old, growing continuously since the age of dinosaurs. The limestone they've created forms entire islands, atolls rising from the deep ocean, where coral has been building for so long that the reef itself is now hundreds of feet thick. But here's what's haunting. Coral reefs are dying faster than at any time in human history. When water temperatures rise too high, coral expels the algae that lives in its tissue and gives it color and food. The coral turns white, bleached, and if conditions don't improve, it dies. These architects of the ocean, builders of structures that have stood for millions of years, are dying within decades. And when they die, they don't disappear immediately. The limestone structures remain, white skeletons of what used to be living cities, gradually being broken down by waves and boring organisms. Divers swimming through recently bleached reefs describe them as ghost towns, empty structures that still show the shape of what lived there, but devoid of life. The ocean is filling with architectural ruins, monuments to ecosystems that existed just years ago, fading slowly back into the sand they came from. Now let's talk about something that sounds like science fiction, but is absolutely real. The ocean contains a record of every nuclear test ever conducted in the atmosphere. From the 1940s through the 1960s, hundreds of nuclear weapons were detonated in the atmosphere. These explosions produced radioactive isotopes that didn't exist naturally on Earth, including carbon-14 in unusual ratios and isotopes like strontium-90. These isotopes settled into the ocean and were absorbed by marine life. They became part of the food chain, part of the water chemistry, part of the sediment. And because we know exactly when these tests occurred, we can use these isotopes as time markers in anything we find from that era. Scientists studying fish can determine the exact year the fish was born by analyzing the radioactive signature in its bones. They can track how nuclear fallout spread through ocean currents by examining the isotope ratios in different locations. The ocean became, inadvertently, a record keeper for the nuclear age. But here's what's sobering. These isotopes will remain in the ocean for thousands of years, slowly decaying, gradually fading, but never truly disappearing. Tens of thousands of years from now, if anyone examines sediment cores from our era, they'll see a distinct layer enriched with radioactive isotopes that don't occur naturally, a permanent marker of the period when humans learned to split atoms and tested that knowledge in the sky above the sea. The ocean remembers our nuclear age, written in isotopes scattered through its depths, a record we can never erase. Let me tell you about bioluminescence again, but from a different perspective. In the deep ocean, bioluminescence isn't rare, it's the norm. An estimated 90% of creatures living below 3,000 feet can produce their own light, but they don't do it constantly. If you could somehow visit the deep ocean with your eyes adjusted to the darkness, you would see something extraordinary. Occasional flashes, brief glows, moving points of light in the vast darkness. It would look like a city at night seen from a great distance, lights turning on and off, some steady, some blinking, some moving slowly through the space. Each light serves a purpose. Some are lures, attracting prey. Some are warnings, telling predators, "I'm toxic, don't eat me." Some are courtship displays. Some are communication between members of the same species. The deep ocean is having conversations in light, messages being passed in bioluminescent flashes that we're only beginning to decode. But here's what's beautiful and strange. Bioluminescence uses different chemical reactions in different species. Some use luciferase enzymes, others use bacterial symbionts. The ability to produce light has evolved independently at least 40 times in marine species, meaning the deep ocean has invented light over and over again, finding different solutions to the same problem: how to see and be seen in the darkness. The ocean's depths are not truly dark. They're filled with subtle illumination, a galaxy of biological stars, each one a creature announcing its presence, its intentions, its very existence to the darkness that surrounds it. The deep ocean glows, softly and intermittently, with the combined light of millions of living lanterns. Our next story is about something that salmon do that seems almost impossible. They find their way home. Salmon are born in freshwater streams, migrate to the ocean to grow and mature, then return to the exact same stream where they were born to spawn and die. Some species travel thousands of miles in the ocean before making this return journey, navigating back to a specific stream, sometimes a specific pool, where they hatched years earlier. How they do this remains partially mysterious. They use magnetic fields, they taste the water chemistry, they may use sun angles and star positions, but the core mystery is how they remember. How does a fish that left a stream when it was inches long return to that same stream years later, after growing to several feet long and travelling thousands of miles through an ocean with no landmarks? The prevailing theory is that they imprint on the specific chemical signature of their birth stream during a critical period of development, and they carry that memory for years through all their wanderings in the ocean until the time comes to return. But here's what's tragic. As rivers become dammed, polluted, or altered, salmon return to streams that no longer exist or no longer match the memory they carry. They arrive at the mouth of their birth river and find it changed, blocked, or empty. Some circle in the ocean, waiting for conditions that will never come. Others push upstream anyway, spawning in degraded habitat where their offspring have little chance of survival. The ocean sends them home, but home is disappearing, and the fish don't know until they arrive that the place they've been navigating toward for years is gone. The last migration, repeated by millions of salmon every year, increasingly ends not in renewal, but in confusion, as instinct meets a changed world and finds no place to complete the ancient cycle. Rest now, knowing that the ocean still calls its creatures home, still maintains the ancient patterns, even as the world changes around them. Let yourself drift on that current of instinct, following the pull toward rest, toward sleep, toward the quiet place where all journeys end and begin again. As you drift deeper into rest, let me tell you about the mountain ranges that cover more of Earth's surface than any mountains on land, yet remain almost entirely unexplored. The mid-ocean ridges form a continuous chain of underwater mountains that wraps around the globe like the seam on a baseball. These ridges stretch for over 40,000 miles, making them the longest mountain range on Earth by far. The Mid-Atlantic Ridge alone is longer than the Andes, Rockies, and Himalayas combined. But here's what makes them remarkable. They're active. These mountains are being built right now as magma wells up from deep within Earth's mantle, creating new ocean floor. The mountains are spreading centers where tectonic plates are pulling apart, and molten rock rises to fill the gap. And at these spreading centers, in the darkness miles below the surface, are hydrothermal vents, underwater geysers that spew superheated water laden with minerals. The water can reach temperatures of over 700 degrees Fahrenheit, hot enough to melt lead, yet just inches away, the water is near freezing. These vents support ecosystems unlike anything else on Earth. Tube worms taller than humans, eyeless shrimp packed so densely they look like drifts of snow, bacteria that derive energy not from sunlight, but from chemicals in the vent fluid. These are ecosystems that don't depend on the sun at all, living on geothermal energy, on the heat of Earth's interior. And we've explored less than 1% of these mountain ranges. There are peaks down there that no human eye has ever seen, valleys that have never been mapped, entire ecosystems that may exist nowhere else. Living in the darkness on mountains we didn't even know existed until the 1950s. Now let me tell you about ambergris, a substance so strange that for centuries people couldn't agree on what it was or where it came from. Ambergris is produced in the intestines of sperm whales, formed around indigestible items like squid beaks. The whale eventually expels it, and it floats on the ocean's surface, drifting with currents, slowly oxidizing and hardening in the sun and salt air. Over months or years, it transforms from a soft, foul-smelling mass into a hard, waxy substance with a sweet, earthy scent. For centuries, people found ambergris washed up on beaches and had no idea what it was. Some thought it was solidified sea foam. Others believed it was a fungus that grew in the ocean. Still others thought it came from underground springs on the ocean floor. It was so valuable that finding a large piece could make someone wealthy, but its origin remained a mystery. What makes this story unsettling is what ambergris represents. It's the ocean's way of preserving and transforming waste. The whale produces it to protect itself from indigestible matter, ejects it, and the ocean takes over, slowly converting it into something beautiful through the action of sun, salt, and time. There are pieces of ambergris floating in the ocean right now, years or decades into their transformation, slowly circling in the gyres, gradually changing from something repellent into something precious. The ocean is patient enough to turn waste into treasure, given time and the right conditions. It makes you wonder what else the ocean is slowly transforming. What other substances are drifting in the currents, undergoing gradual metamorphosis that won't be complete for years or decades to come. Let me tell you about something discovered at hydrothermal vents that changed our understanding of where life can exist. Extremophiles, organisms that thrive in conditions that should be instantly lethal. At the vents, bacteria live directly in the plumes of superheated, mineral-rich water. They've evolved to not just survive, but require temperatures above boiling point. If you cooled them down to room temperature, they would die, unable to function in what we consider normal conditions. Some of these bacteria divide and reproduce faster at higher temperatures, growing optimally around 250 degrees Fahrenheit. Their proteins are structured differently. Their DNA is protected by specialized molecules. Their cell walls are composed of materials that remain stable at temperatures that would destroy normal cells. But here's what's profound. These organisms may represent some of the oldest forms of life on Earth. The earliest living things probably emerged in environments similar to hydrothermal vents, feeding on chemical energy rather than sunlight. These bacteria aren't just surviving in extreme conditions. They may be living the way life first lived billions of years ago. And they've forced us to reconsider what habitable means. If life can thrive in boiling water, in complete darkness, under crushing pressure, feeding on chemical energy alone, then the definition of where life might exist expands dramatically. Every extreme environment we discover on Earth, every place we thought was too hostile for life, potentially hosts organisms we haven't found yet. The ocean keeps revealing that life is more tenacious, more adaptable, more persistent than we imagined. It finds ways to exist in places we thought were absolutely lifeless, proving over and over that our assumptions about the limits of life are too narrow. Now let me tell you about something that happens in the ocean that can trap entire populations of marine life. Hypoxic events, or what researchers call dead zones, but in more detail than before. These dead zones form when algae blooms die and sink to the bottom, where bacteria consume them. The bacteria use up all available oxygen in the water, creating areas where oxygen levels drop to near zero. Fish, crabs, and anything that needs to breathe finds itself in water that can't support life. The frightening thing about these events is how quickly they can develop. A healthy ecosystem can become a dead zone in a matter of days. Creatures that can swim fast enough escape. Everything else suffocates where it lived. But here's what's particularly eerie. These dead zones can persist for months. The low oxygen water sits on the bottom like a layer of poison, and because it's denser than oxygenated water, it doesn't mix. It just sits there, a pocket of death in the ocean, invisible from the surface. Bottom-dwelling creatures entering these zones essentially walk into invisible chambers with no air. Crabs have been filmed walking into hypoxic zones and collapsing within minutes, their bodies adding to the carpet of dead organisms already on the seafloor. The boundaries of these zones are littered with the bodies of things that couldn't turn back in time. And they're growing larger and more frequent. There are now over 400 documented dead zones worldwide, and that number increases each year. Parts of the ocean are becoming uninhabitable, gasping for oxygen they can't obtain. While on the surface, everything appears completely normal. The ocean is suffocating from below, quietly, invisibly, in expanding pockets of airless water. Let me tell you about creatures that have been swimming in the ocean longer than almost anything else alive. Horseshoe crabs, though they're not really crabs at all. Horseshoe crabs have existed largely unchanged for over 400 million years. They were ancient when dinosaurs first appeared. They survived the mass extinction that killed the dinosaurs. They've persisted through ice ages, asteroid impacts, and dramatic changes in ocean chemistry and temperature. The horseshoe crab that washes up on a beach today is essentially identical to horseshoe crabs that lived when the first fish were crawling onto land. But here's what makes them remarkable beyond their antiquity. Their blood is blue, copper-based rather than iron-based, and it has unique properties that make it invaluable to modern medicine. Their blood cells will instantly clot when exposed to bacterial toxins, making it the perfect test for contamination in medical equipment and vaccines. Every year, hundreds of thousands of horseshoe crabs are collected, bled, and returned to the ocean. Most survive, but some don't. And here's the unsettling part. We're harvesting a creature that has survived for 400 million years, that survived catastrophes that destroyed most life on Earth, and using it in ways that might finally be the thing that reduces their numbers below sustainable levels. These ancient mariners, older than trees, older than flowers, older than most forms of complex life, persisted through nearly 500 million years of Earth's history. And in just a few decades of human medical use, their populations have begun to decline. The ocean has kept them alive through eons of change, but it may not be able to protect them from us. Now let me tell you about something that exists in the ocean that seems to defy nature. Brine pools, pockets of extremely salty water on the ocean floor that are so dense that they form actual pools with distinct surfaces, complete with waves and shorelines. These pools form when ancient salt deposits buried beneath the seafloor dissolve and seep upward. The resulting brine is so much denser than regular seawater that it doesn't mix. It settles into depressions on the ocean floor, creating what looks like a lake within the ocean. The water in these pools is often 4 to 5 times saltier than normal seawater, making it toxic to most marine life. Creatures that swim into the brine pools die almost instantly, preserved in the supersaline water. The shores of these underwater lakes are littered with the bodies of fish and crabs that wandered in and never emerged. But here's what's eerie. These pools have been there for thousands of years, slowly growing as more brine seeps up from below. Some are hundreds of feet across, literal lakes on the ocean floor, with their own chemistry, their own circulation patterns, even their own specialized bacteria that can survive in the extreme salinity. Submarines exploring these pools describe it as surreal, descending through normal seawater, then suddenly encountering a surface, and below that surface, different water with different properties, sitting at the bottom of the ocean like a trap, waiting for anything curious or unlucky enough to enter. The ocean has layers within layers, water within water, and some of those layers are deadly, sitting undisturbed for millennia, slowly claiming victims that drift down from above. Let me tell you about phytoplankton, but consider them not just as microscopic plants, but as the most important organisms in the ocean, possibly on Earth. These single-celled organisms, invisible to the naked eye, collectively produce more oxygen than all the rainforests on the land combined. They form the base of nearly every ocean food web. They pull carbon dioxide from the atmosphere and sink it to the deep ocean when they die. They've been doing this for billions of years, shaping Earth's atmosphere and climate. But here's what's remarkable. Their populations fluctuate wildly. Satellite images of the ocean can show phytoplankton blooms hundreds of miles across, turning the water milky green with the sheer density of microscopic life. These blooms can appear in days, persist for weeks, then vanish just as quickly. When these blooms die, they sink, and as they decompose, they can create those dead zones we discussed earlier. The most important organisms in the ocean, the ones producing the oxygen you're breathing right now, can also create zones of death when they collapse. And they're changing. Ocean warming is affecting phytoplankton distribution and abundance. Some areas that used to bloom reliably no longer do. Others are blooming at different times of year, disrupting the food webs that depend on their predictable cycles. Think about that. The invisible forests of the ocean, the primary producers of planetary oxygen, are shifting and changing in response to warming, and we can't predict what that will mean for ocean ecosystems or for the atmosphere itself. The smallest things in the ocean might have the largest impact on everything else, and they're responding to changes we're causing but can't control. Have you heard whale songs? But not just as beautiful music. Consider them as feats of communication that span ocean basins. Humpback whales sing complex songs that can last for hours. These songs evolve over time, with new phrases appearing and old ones disappearing. Whales in the same population sing the same song, and when the song changes, all the whales in that population adopt the changes, suggesting some form of cultural transmission. But here's what's extraordinary. These songs can travel for hundreds, sometimes thousands of miles through the ocean. A whale singing near Hawaii can potentially be heard by whales near Alaska, the sound traveling through the SOFAR channel we discussed earlier, spreading across the entire Pacific. And we don't fully understand why they sing. The songs are primarily produced by males, suggesting they might be related to mating, but females don't seem to choose mates based on the songs. Some researchers believe the songs might be more about male competition or group cohesion. Others think there might be information encoded in the songs that we haven't learned to decode. What's haunting is that whale songs are getting louder. As ocean noise from shipping increases, whales are having to sing louder to be heard over the background din. Studies comparing recordings from the 1960s to today show a measurable increase in volume. The whales are compensating for noise pollution by essentially shouting, putting more energy into their songs to cut through the mechanical rumble of propellers and engines. The ocean used to be full of whale song, vast acoustic spaces where calls could travel for thousands of miles. Now it's increasingly filled with human noise, and the whales are having to raise their voices just to be heard, expending more energy on communication in an ocean that gets noisier every year. Our next story is about the creatures that live in the Hadal Zone, the deepest parts of the ocean trenches, below 20,000 feet. Life at these depths faces pressures over 8 tons per square inch. Water is compressed to the point where it actually becomes slightly denser than you'd expect. The darkness is absolute and eternal. The temperature is just above freezing. Food is scarce, limited to whatever drifts down from the upper ocean. Yet life exists there. Snailfish have been found at depths over 26,000 feet, deeper than Mount Everest is tall. They're not just surviving, they're functioning normally, swimming, feeding, reproducing. Their bodies are adapted in ways that make them unable to survive at shallower depths. The pressure they live under would crush most organisms instantly, but to them, it's normal. These fish have extremely flexible bones, bodies with high water content, special proteins that remain stable under extreme pressure. They're built for the Haddle zone, and only the Haddle zone. If you brought one to the surface, it would quite literally fall apart, its proteins denaturing, its cellular structure failing as the pressure decreased. What's profound is that these creatures represent the absolute limit of where complex life can exist in Earth's oceans. Below them, eventually, is a depth where even these adaptations aren't enough, where the pressure becomes so extreme that the chemistry of life itself can't function. Somewhere in the deepest trenches is the boundary between where life can exist and where it cannot. And we haven't found that boundary yet. The ocean's deepest parts are inhabited right down to the limit of what's physically possible. Life pushing against the absolute constraints of chemistry and physics, persisting in the last possible place it can exist. Rest now in the knowledge that life finds a way, even in the darkest, most hostile environments imaginable. Let yourself sink peacefully into sleep, settling gently like snow through dark water, finding your rest in the quiet depths where pressure and peace are the same thing. As you settle even deeper into rest, let me tell you about rogue waves, phenomena that sailors reported for centuries but scientists dismissed as maritime folklore until quite recently. A rogue wave is typically defined as a wave at least twice the height of the surrounding waves. These aren't tsunamis, which are caused by earthquakes. They're not storm surges. They're spontaneous formations that appear in the open ocean, seemingly from nowhere. Towering walls of water that can reach over 100 feet high. For decades, scientists believed these waves were physically impossible, that the ocean couldn't generate such extreme waves without extraordinary circumstances. Sailors who reported encountering them were thought to be exaggerating or mistaken. Then, on New Year's Day, 1995, an oil platform in the North Sea recorded a wave exactly matching these descriptions. 85 feet high, appearing suddenly in seas where surrounding waves were only 40 feet. It was measured by instruments, undeniable proof that rogue waves were real. Since then, we've learned that rogue waves are more common than anyone suspected. Satellite data suggests that at any given moment, there are several rogue waves somewhere in the world's oceans. They form when multiple wave trains intersect at just the right angle, their energies combining into a single, massive surge. But here's what's unsettling. They're unpredictable. There's no reliable way to forecast when or where they'll appear. They strike ships with tremendous force, sometimes breaking over the bow with enough weight to crush superstructures or snap vessels in half. Several large ships disappear each year in conditions that shouldn't have been severe enough to sink them. Rogue waves are now suspected in many of these losses. The ocean can suddenly reach up and strike with focused violence, and we can't predict when it will happen. The geometry of waves occasionally aligns to create monsters, and then they disappear back into the surrounding sea as quickly as they emerged. Now let me tell you about something the ocean does constantly but invisibly. It's eroding the land, grain by grain, and has been doing so since continents first rose above the water. Every coastline on Earth is temporary. Waves striking the shore transfer enormous energy, gradually breaking down rock, carrying away sediment. In some places, entire cliffs collapse into the sea during storms. In others, beaches slowly migrate or disappear. Islands shrink and eventually vanish beneath the waves. But here's what makes it profound. The ocean is patient. It doesn't need to destroy a cliff in one storm. It can take 1,000 years, 10,000, 1,000,000. Time is on its side. Eventually, every mountain that rises near the coast will be worn down and carried away by the waves. And where does all that sediment go? Some of it forms new beaches elsewhere. Some of it gets carried out to the continental shelf. Much of it eventually settles on the abyssal plains, adding to the layers of sediment accumulating there, turning mountains into mud, grain by grain. The continents themselves are temporary. They rise through tectonic forces and then slowly erode back into the ocean. Every grain of sand on a beach was once part of a mountain. Every particle of mud on the ocean floor was once solid rock. The ocean is patient enough to reduce mountains to dust, and it's been doing this work since the beginning. Right now, as you rest, waves are striking coastlines around the world, each one carrying away microscopic amounts of land, continuing the eternal work of returning the continents to the sea. The ocean is reclaiming everything, slowly but inevitably, with the patience of deep time. Let me tell you about something that exists throughout the ocean but is invisible to us: electric fields generated by marine life. Many sea creatures can sense electrical fields, and some can generate them. Sharks have organs called ampullae of Lorenzini that can detect electrical fields as weak as 1/1000th of a volt. They use this sense to find prey buried in sand, to navigate using Earth's magnetic field, even to sense the muscle contractions of other animals hiding nearby. Electric rays and electric eels can generate powerful shocks, hundreds of volts, enough to stun prey or deter predators. But most marine creatures produce much weaker fields, bioelectrical signals created by the normal functioning of muscles and nerves. The ocean is filled with these signals, a constant background of electrical noise created by millions of living things. To a shark, the ocean isn't just filled with chemical scents and sounds, it's alive with electricity. Every creature announcing its presence through the electrical fields it generates simply by being alive. But here's what's strange. Human activity is adding artificial electrical noise to the ocean. Undersea power cables, offshore wind farms, ship hulls with different metal components that create galvanic currents, all of these add electrical signals to the water. We're potentially confusing the navigation and hunting abilities of creatures that depend on sensing electrical fields. Imagine if suddenly the air was filled with random sounds that mimicked voices, making it hard to distinguish real speech from noise. That's potentially what we're doing to the electrical environment of the ocean, filling it with artificial signals that blur the natural electrical landscape these creatures evolved to sense. The ocean has always been electric, alive with the fields generated by living things. Now it's becoming electrically polluted, and we don't fully understand what that means for the creatures that live in a world of electrical sensation we can't perceive. Now let me tell you about something found in certain parts of the deep ocean floor that seems almost malevolent: fields of manganese spires. In some areas of the abyssal plains, particularly in the Pacific, the seafloor is covered with tall, thin spires of manganese oxide, some reaching several feet high. They're formed through chemical processes we don't fully understand, minerals precipitating out of seawater and accreting into these needle-like structures over thousands of years. These spire fields can cover vast areas, thousands of them clustered together like an underwater forest of mineral needles. They're fragile, brittle, but also sharp. Any creature navigating through them risks injury, but here's what's unsettling. These formations were completely unknown until deep-sea cameras began surveying the ocean floor. We had no idea they existed until we actually looked. And because they grow so slowly and form in specific chemical conditions, each field is unique, a one-of-a-kind mineral garden that took millennia to form. And now, as we prepare for deep-sea mining, these fields are in danger of being destroyed. A mining operation dragging equipment across the ocean floor would shatter these spires into dust, erasing in minutes what took thousands of years to form. The ocean floor isn't flat and featureless. It's covered in structures and formations we're only beginning to document, each one unique, each one the product of deep time and specific conditions. And we're preparing to modify the seafloor before we've even finished surveying what's there, potentially destroying things we haven't even discovered yet. Let me tell you about something that happens to ships when they sink. The air trapped inside creates a final bubble that rises to the surface, often hours, or days after the vessel has gone down. When a ship sinks, if parts of it remain sealed, those sealed compartments hold air. As the ship settles on the ocean floor and pressure works on the hull, eventually that air escapes. Sometimes it comes out slowly, bubbles rising continuously for days. Sometimes compartments fail all at once, releasing large volumes of air that create dramatic eruptions on the surface. Sailors in the area where a ship has sunk sometimes report seeing the water suddenly boil with bubbles, or seeing large air pockets burst at the surface, each one carrying with it a smell of fuel, oil, sometimes other odours from the interior of the sunken vessel. It's called the ship's last breath, the final release of air from a vessel now resting on the bottom. But here's what makes it eerie. Sometimes these air releases happen long after the sinking, when everyone has given up and gone home. Days later, sometimes weeks later, the air finds a way out. Fishermen occasionally report seeing unexpected areas of bubbling water, and when investigated, they're found to be directly over recently sunken vessels, the ships releasing their trapped air in a final exhalation. It's as if the ship is sighing one last time, releasing what it held inside, accepting its new existence on the ocean floor. And with that final breath goes the last physical connection to the surface world. The last remnant of air from above, now rising through the water to rejoin the atmosphere it came from. Now let me tell you about eddies, massive rotating currents that spin off from major ocean currents and travel across the ocean like underwater weather systems. These eddies can be hundreds of miles across, rotating for months or even years before dissipating. They're not surface phenomena. They extend thousands of feet deep, carrying water of different temperature and chemistry than the surrounding ocean. A warm core eddy spun off from the Gulf Stream might carry warm Caribbean water north into the Atlantic, maintaining its warmth and rotation for months as it slowly drifts. But here's what's remarkable. These eddies transport nutrients, larvae, plankton, even adult fish, carrying them far from their normal habitats. An eddy spinning off from one current system might capture creatures from that region and transport them hundreds or thousands of miles, releasing them in completely different waters when the eddy finally breaks down. This means the ocean is constantly shuffling its inhabitants, mixing populations, spreading species to new areas through these rotating currents. An eddy is like a ship, but instead of carrying cargo deliberately, it captures whatever happens to be in the water when it forms, then transports it across the ocean. And we can track them now with satellites, watching these massive rotating features drift across the ocean like slow-motion hurricanes in the water. At any given time, there are hundreds of these eddies in the world's oceans, each one a traveling ecosystem, each one moving water and life from one region to another. The ocean is never still. Even when the surface appears calm, below there are massive structures of rotating water, miles across and thousands of feet deep, slowly spinning their way across the basins, mixing and transporting everything they contain. Let me tell you about something found in the deep ocean that shouldn't exist. Shipwrecks with human remains still inside, perfectly preserved by the cold and the absence of oxygen. In the deep parts of the ocean, particularly in areas with low oxygen levels, decomposition happens extremely slowly. Wood doesn't rot in the normal way. Fabric doesn't decay. Even organic materials can persist for decades or centuries, largely unchanged. When researchers explore deep shipwrecks, they sometimes find the interiors remarkably preserved. Dishes still stacked in the galley, clothing still hanging in lockers, personal effects scattered exactly where they fell when the ship went down. And occasionally they find human remains, sometimes intact enough that identification would be possible if anyone was still looking. These aren't skeletons. In the cold, oxygen-poor water, soft tissue can remain for decades. What they find are people, essentially mummified by the unique conditions of the deep ocean, still present in the ships where they died. It raises profound questions about what to do with these wrecks. They're graves, but they're also archaeological sites, historical records. Do we leave them undisturbed as memorials, or study them to learn what we can? Different cultures and maritime traditions answer this differently. But here's what's certain. There are ships on the ocean floor right now. Some of them with people still inside, preserved in the cold and dark, waiting in a silence that has lasted decades or centuries. The deep ocean doesn't just hide things, it preserves them, holding them in a state of suspension where time moves differently, where the past remains present in ways that feel impossible, but are absolutely real. Now let me tell you about coelacanths, fish that were thought to be extinct for 65 million years until one was caught off the coast of South Africa in 1938. Scientists had only known coelacanths from fossils. They were fish from the age of dinosaurs, primitive lobe-finned fish that were thought to have died out in the same mass extinction that killed the dinosaurs. Finding a living coelacanth was like finding a living dinosaur. But here's what makes them remarkable. They haven't changed. The coelacanths swimming in the ocean today are nearly identical to their fossilized ancestors from hundreds of millions of years ago. They found an ecological niche in the deep, cool waters off certain coasts, and they've stayed there, largely unchanged, while the world above evolved and changed dramatically. They're slow-moving, living in caves and underwater canyons during the day, emerging at night to hunt. They can live for 60 years or more. They give birth to live young after a gestation period of over a year. In every way, they're unlike most modern fish, relics of an ancient ocean persisting in pockets where conditions remain similar to what they were millions of years ago. And here's the unsettling part. We almost never see them. They live deep enough and in specific enough locations that they remained unknown to science for the entire modern era. How many other living fossils might be down there? Species we think are extinct, but are actually persisting in the deep, unknown and undiscovered. The ocean keeps secrets, and sometimes those secrets are entire species that evolution left behind, but the ocean protected, maintaining ancient forms of life in refuges where the modern world hasn't penetrated. Our next story is about something unique to maritime disasters. The witnesses who survive often carry the memory alone, because everyone else who could verify their experience is gone. When a ship sinks far from shore, the survivors, if any, are often the only people who know exactly what happened. They saw the sequence of events. They experienced the final moments. They know details that will never be recorded anywhere else. And often, that burden becomes heavy. Survivors of maritime disasters describe a particular kind of trauma, different from other accidents because the ocean leaves so little evidence. The ship is gone, beneath the water. The others who were aboard are gone. There's no wreckage to examine, no crash site to investigate. Just water, appearing exactly as it always does, revealing nothing of what happened beneath it. And survivors sometimes report feeling as if the event didn't really happen, as if it was a hallucination, because the ocean has erased all physical evidence so completely. They're left holding memories of something catastrophic that the world shows no signs of, an event that might as well have occurred in another dimension for all the trace it left behind. The ocean is a perfect eraser of human activity. A ship can sink, and within hours, the surface appears completely undisturbed. No fire trucks remain at the scene, no skid marks on the road, no debris field. Just water, looking exactly as it did before, as if nothing had happened. And so survivors carry their memories into a world that shows no evidence of what they witnessed, becoming the sole archives of events that the ocean has already erased, keeping alive the memory of things that have been perfectly removed from the physical world. Rest now, knowing that the ocean remembers in its own way, even as it hides evidence from the surface. Let yourself drift deeper into sleep, releasing the weight of consciousness, settling into the quiet darkness where memory and dreams merge, where the boundary between what was and what might be dissolves like salt in water. Let me tell you about pumice rafts, floating islands of volcanic rock that drift across the ocean like ghost ships made of stone. When certain types of underwater volcanoes erupt, they produce pumice, a rock so filled with air bubbles that it floats. Sometimes these eruptions create vast fields of floating pumice, rafts that can be hundreds of square miles in size, drifting with ocean currents for months or years. These rafts are visible from space, massive grey-white patches on the ocean that can be mistaken for ice. Ships encountering them report an eerie experience. The vessel slows as it pushes through the pumice. The water becomes thick with floating stone, and a strange grinding sound fills the air as millions of rocks scrape against the hull. But here's what makes them remarkable. These pumice rafts become floating ecosystems. Barnacles, algae, and other marine organisms colonize the rocks. Small fish shelter beneath them. Seabirds land on them to rest. The rafts become temporary islands, transporting life across the ocean as they drift. When they finally become waterlogged and sink, usually after several months, they carry their passengers down with them. Organisms that evolved for surface life find themselves sinking into the deep, still attached to the rocks that betrayed them. The ocean floor in areas where pumice rafts commonly sink is littered with these colonized stones, memorials to temporary islands that drifted for a while, then descended into the darkness. The ocean occasionally creates land, but that land is always temporary, always in motion, always destined to sink eventually and carry whatever trusted it back down into the deep. Now let me tell you about a boundary that exists in most of the ocean, a layer you can pass through in seconds, but that divides the ocean into fundamentally different worlds. The thermocline. The thermocline is a layer where temperature drops rapidly with depth, usually found between 300 and 3,000 feet down, depending on location. Above it, water is warm, mixed by waves and heated by the sun. Below it, water is cold, dark, and relatively still. Divers who descend through the thermocline describe it as shocking. One moment, you're in water of one temperature, and within a few feet, it suddenly becomes much colder. The visibility often changes too, as the water below the thermocline is usually clearer, less filled with plankton and suspended particles. But here's what makes it significant. The thermocline acts as a barrier. Nutrients that sink from the surface often accumulate at the thermocline, unable to mix upward into the surface layer. Sound behaves differently as it crosses this boundary. Submarines can hide beneath it, difficult to detect from above because sonar signals reflect off the temperature gradient. The thermocline divides the ocean into layers that don't mix easily, each with its own chemistry, its own ecology, its own physics. It's a boundary you could swim through, feeling the temperature drop on your skin, but it might as well be a wall for all the separation it creates between the upper and lower ocean. And in a warming world, the thermocline is getting stronger in some places, the temperature difference between surface and deep water increasing. This means less mixing, less nutrient exchange, potentially less productivity in the surface waters that depend on nutrients from below. The boundary is hardening, dividing the ocean more rigidly into separate realms. Let me tell you about hagfish, creatures so strange they seem designed to unsettle anyone who learns about them. Hagfish are not really fish at all, despite the name. They're more primitive, lacking jaws, and having a skull made of cartilage rather than bone. They've been around for over 300 million years, largely unchanged, bottom dwellers that feed on dead or dying creatures on the seafloor. But here's what makes them remarkable. When threatened, they produce slime. Not just a little slime, but enormous quantities of thick, fibrous slime that can clog the gills of predators and cause them to release the hagfish immediately. A single hagfish can turn a bucket of water into slime in seconds. The slime is produced by special glands and consists of mucus and protein threads that expand when exposed to seawater. It's so effective that researchers are studying it for potential applications in materials science, creating fibers that are stronger than spider silk. But hagfish have another unsettling behavior. They tie themselves in knots. They use their bodies like a tool, sliding a knot along their length to gain leverage when feeding, or to scrape slime off themselves, or to anchor themselves while burrowing into a carcass, and they burrow into dead things. When a whale or large fish dies and sinks to the bottom, hagfish are often the first to find it. They burrow into the carcass through any opening they can find and eat it from the inside out, sometimes dozens of hagfish occupying a single carcass, hollowing it out over weeks. The ocean floor is patrolled by these ancient, slime-producing creatures that tie themselves in knots and burrow into the dead, performing essential cleanup services that keep the deep ocean from being buried in carcasses. They're bizarre, unsettling, and absolutely vital to the ecosystem of the deep. Now let me tell you about something that happens occasionally in certain parts of the ocean. Perfect calm, where the water becomes so still, it reflects like a mirror. This typically happens in areas of high pressure, where wind drops to nothing, and the ocean surface, no longer disturbed by even the slightest breeze, becomes perfectly flat. Sailors call it glassy calm, or sometimes the doldrums, though true doldrums have different causes. In these conditions, the ocean's surface becomes a perfect mirror. The sky reflects so clearly that it becomes disorienting. Looking at the water is like looking into another sky. If there are clouds, they're reflected perfectly. At night, stars reflect in the water, creating the illusion that you're floating through space. Stars above and below. Sailors describe these periods as unsettling despite their beauty. The boat sits motionless, no wind to fill the sails, no waves to rock the hull. The silence is profound. The reflected sky creates a sense of vertigo, as if the normal rules of up and down have been suspended. Some sailors report feeling unmoored from reality during extended periods of glassy calm, as if they've drifted into a space between worlds. And in that perfect calm, any disturbance is amplified. A fish breaking the surface creates ripples that spread for hundreds of feet, visible from far away. A bird landing creates a splash that shatters the mirror momentarily before the surface smooths again. The ocean, in perfect calm, isn't peaceful so much as it is strange, a temporary suspension of the usual chaos, a moment where the water remembers that it can be still, that beneath all the wave action and storm force, it's fundamentally just lying there, waiting, capable of perfect peace when the wind allows it. Let me tell you about artificial reefs, but not as human creation helping the ocean. Consider them as human structures that the ocean has claimed and transformed. When ships sink, when oil platforms are decommissioned and toppled, when concrete structures are deliberately placed on the ocean floor, the ocean begins converting them into reef habitat almost immediately. Within days, a film of bacteria covers the surfaces. Within weeks, algae and barnacles appear. Within months, fish arrive. Eventually, these artificial structures become indistinguishable from natural reefs in terms of the life they support. Coral colonies grow on sunken ships. Fish shelter in the nooks and compartments. Entire ecosystems establish themselves on human wreckage. But here's what's profound. We're accidentally creating underwater cities. The ocean floor around major shipping lanes, around industrial areas, around naval bases, is littered with human structures that have become habitats. Hundreds of thousands of shipwrecks, thousands of downed aircraft, countless pieces of industrial equipment, all slowly being converted into reef. In the Gulf of Mexico alone, There are over 40,000 oil and gas platforms, many of them now serving as artificial reefs. When they're decommissioned, the question becomes, remove them or leave them as habitat. The ocean has already claimed them, already integrated them into its ecosystems. We're creating a new kind of ocean floor, one peppered with human structures that the ocean is patiently converting into something natural. Future marine archaeologists studying the ocean floor thousands of years from now will find a layer of human-made reefs, a distinctive marker of our era, when we accidentally created habitat by losing or abandoning our structures in the sea. The ocean doesn't distinguish between natural rock and human steel. It colonizes both, converting everything into reef, patient and thorough, in its work of claiming whatever falls into its domain. Now let me tell you about something that exists in certain parts of the ocean floor that's both fascinating and potentially dangerous: methane seep communities. In some locations, methane gas seeps up from beneath the seafloor, either from geological sources or from frozen methane hydrates that are gradually melting. This methane creates unique ecosystems, supporting bacteria that can metabolize it, and those bacteria in turn support entire communities of specialized organisms. Giant tube worms, massive clams, bacterial mats that look like white or yellow carpets. All of these thrive around methane seeps, deriving their energy ultimately from the methane rather than from sunlight. They're chemosynthetic ecosystems, powered by chemistry rather than photosynthesis. But here's what's concerning. Methane is a powerful greenhouse gas, and vast amounts of it are frozen in the ocean floor in the form of methane hydrates. As ocean temperatures rise, these hydrates can become unstable and release their methane. If enough methane releases rapidly, it could have dramatic effects on climate and ocean chemistry. Some scientists believe past mass extinctions may have been triggered or accelerated by massive methane releases from the ocean, and we're seeing signs that it's happening now. Areas of the Arctic Ocean that were previously stable are beginning to show increased methane seepage. The permafrost beneath the shallow Arctic seas is thawing, potentially releasing methane that's been frozen for thousands of years. The ocean floor is holding vast reserves of a gas that could dramatically alter Earth's climate, and that gas is slowly being released. The ecosystems that thrive on methane seeps might be early warnings, places where we can observe what happens when frozen methane returns to the ocean and atmosphere. Let me tell you about the life cycle of sea turtles, which involves a journey so improbable it seems almost impossible that the species survives. Sea turtles hatch on beaches, dig themselves out of the sand, and immediately head for the ocean. Once they enter the water as hatchlings, they begin a journey that can last decades. Some species, like loggerheads, travel around entire ocean basins, following currents in great circular routes that can take years to complete. They feed, grow, mature, all while swimming in the open ocean, following currents and food sources. And then, when they're ready to breed, they return to the beach where they hatched, sometimes traveling thousands of miles to get there. How they navigate back to the specific beach from anywhere in the ocean remains partially mysterious. They use Earth's magnetic field. They may use chemical cues. They might remember the imprint of the beach from when they were hatchlings. But the fact remains, they leave the beach as tiny hatchlings and return decades later, now massive adults, finding the same stretch of sand in an ocean with thousands of miles of coastline. But here's what's tragic. Many of these beaches are disappearing. Rising seas, development, erosion, light pollution that confuses hatchlings, all of these are eliminating nesting beaches. Turtles return to beaches where they can no longer successfully nest, or they find the beach has been replaced by seawalls or hotels. The ancient cycle is breaking. Turtles evolved this incredible navigation, this improbable life history over millions of years. And now, within a few decades, we're removing the beaches they depend on, breaking a cycle that has persisted since long before humans existed. The ocean still calls them home, but home is vanishing, and there's no backup plan in their genetics, no alternative programmed into their navigation instincts. Now let me tell you about something submarines do that creates a unique kind of awareness. They descend until they can hear the ocean floor. Submarines navigating in deep water use sonar, sending out pings and listening for returns. But at extreme depths, they can sometimes hear the ocean floor directly, not through sonar returns, but through ambient sound. The settling of sediment, the movement of creatures, sometimes even the creaking of geological structures as tectonic plates shift. Submarine crews describe this as profoundly unsettling. They're encased in steel, floating in darkness, and they can hear the ground beneath them, even though it's thousands of feet below. It's like being in an airplane and hearing the ground, a reminder of the distance and the danger, the vast empty space between your vessel and the solid earth below. And sometimes they hear other things. The breaking up of ice far above them if they're in polar regions, the calls of whales that penetrate down to their depth, the sound of distant ships' propellers carried through the SOFAR channel from hundreds of miles away. The submarine becomes a listening station, isolated in the deep, receiving sounds from all directions, above and below, near and far. The crew exists in an acoustic bubble, aware of the ocean around them only through sound, navigating through a world they can hear but not see. And occasionally, they hear sounds they can't identify, metallic groans, rhythmic pulses, strange echoes. Most of these probably have mundane explanations, but in the darkness of the deep ocean, enclosed in a metal tube with thousands of feet of water pressing in from all sides, unexplained sounds take on an outsized psychological weight. The ocean makes noise, constant noise, and most of it is mysterious until you learn what you're listening to. And even then, some sounds remain unexplained, part of the ocean's vocabulary that we haven't yet learned to translate. Our next story is about something beautiful and strange found in certain deep-sea environments: glass sponge gardens. Glass sponges, also called hexactinellids, are sponges whose skeletons are made of silica, essentially glass. They grow in deep, cold waters, forming structures that can be several feet tall and hundreds of years old. Their skeletons are elaborate lattices of glass fibers, beautiful and delicate, filtering water to extract nutrients. In some locations, particularly off the coast of British Columbia, these sponges grow in dense concentrations, creating underwater forests of glass. These gardens can cover areas of several square miles, thousands of sponges growing together, some of them ancient, some over 1,000 years old. But here's what makes them remarkable. They're incredibly fragile and incredibly rare. Bottom trawling fishing gear dragged through these gardens destroys them completely, shattering structures that took centuries to grow. Once destroyed, they don't recover on human timescales. A glass sponge garden that's demolished is effectively gone permanently. And they host unique ecosystems. Shrimp, rockfish, and other creatures shelter in the sponge forests, using them like coral reefs. Some species are found almost exclusively in glass sponge gardens, adapted to this specific habitat. We're only now discovering and mapping these gardens, and some have already been destroyed before we even knew they existed. The ocean floor has these pockets of ancient, delicate beauty, glass forests growing slowly in the darkness, and we're blindly dragging weighted nets through them, turning centuries of growth into silica dust in minutes. Rest now in the knowledge that beauty exists in the deep places, hidden gardens of glass growing in darkness, patient and persistent. Let yourself settle like sediment drifting down through still water, finding peace in the knowledge that the ocean creates wonders, even when no one can see them. Let me tell you about something that flows through the ocean in ways we're only beginning to understand: nutrient highways. Certain ocean currents, particularly upwelling zones where deep water rises to the surface, create pathways of extraordinary productivity. These are the ocean's fertile regions, where nutrients from the deep are brought up to the sunlit surface layer, fueling massive blooms of phytoplankton. These blooms attract small fish, which attract larger fish, which attract predators, creating concentrations of marine life that can be staggering. Some of the world's most productive fisheries exist in upwelling zones, places where the deep ocean's nutrients are continuously delivered to the surface. But here's what's remarkable. These nutrient highways are narrow and specific. Satellite images show them as ribbons of green cutting through otherwise blue ocean, visible from space as lines of high productivity surrounded by relative desert. The ocean isn't uniformly productive. It's structured into zones, and most of it is actually quite barren. And these highways are shifting. As ocean circulation changes with warming, upwelling zones are moving, weakening in some areas, intensifying in others. Entire ecosystems that depend on these nutrient deliveries are having to relocate or adapt, following the shifting patterns of productivity. The ocean has veins carrying life-giving nutrients, and those veins are moving, changing their paths as the ocean's circulation reorganizes itself in response to a warming world. What was fertile becomes barren, what was barren becomes productive, and the creatures that depend on these patterns must adapt or perish. Now let me tell you about something found in ocean sediments that shouldn't have survived but did. Ancient DNA. When organisms die in the ocean, their bodies sink and become part of the sediment. Usually, DNA degrades quickly, broken down by bacteria and chemical processes. But in certain conditions, in very cold water with low oxygen, DNA can persist for surprisingly long periods. Researchers drilling sediment cores from the ocean floor have found DNA fragments that are thousands, sometimes tens of thousands of years old. This DNA tells stories about what lived in that part of the ocean in the past, revealing ecosystems that no longer exist. In some cores, they've found DNA from species we thought only lived in different regions, suggesting that ocean circulation patterns were once very different. In others, they've found DNA from organisms that no longer exist anywhere, species that went extinct but left genetic traces in the mud. But here's what's profound. This ancient DNA is fragmentary and degraded. It's not like finding a frozen mammoth with intact cells. It's more like finding burned pages from a library, enough to know books existed, sometimes enough to read a few words but never the complete story. The ocean floor is an archive of genetic information, a record of what swam and lived and died in these waters going back thousands of years. But it's an archive written in a language we're only learning to read, on pages that are damaged and incomplete, telling us that there's a history here, but making us work to decipher it. Every sediment core is a time capsule, and some of those capsules contain information about species and ecosystems that have vanished, leaving only molecular traces in the mud to prove they ever existed. Let me tell you about something that happens on beaches that few people notice. The sand breathes. Sandy beaches aren't just piles of inert sediment. They're ecosystems filled with life. Bacteria, tiny crustaceans, worms, all living in the spaces between the sand grains. And this ecosystem respirates, consuming oxygen and producing carbon dioxide, literally breathing like a living organism. At low tide, air penetrates into the sand, and the organisms living there consume oxygen from that air. At high tide, the sand becomes saturated with water, and the oxygen must come from the water itself. The beach is constantly exchanging gases with its environment, breathing with the rhythm of the tides. You can measure this. Scientists studying beach ecosystems have found that beaches consume surprising amounts of oxygen, comparable to other coastal ecosystems. The sand is alive with microscopic activity, and that activity requires oxygen just like any other respiration. But here's what makes it eerie. You can sometimes see evidence of this breathing. In some beaches, at certain times, you might notice small holes in the sand that seem to pulse, drawing in water and expelling it rhythmically. These are the burrows of creatures living in the sand, and their activity creates visible patterns of the beach's respiration. The sand beneath your feet on a beach is alive, breathing, consuming, processing. What appears to be simple geology is actually a living skin stretched over the boundary between land and sea, participating in the gas exchange that connects ocean and atmosphere. Every beach is breathing right now with the tides, a slow respiration that has continued for as long as there have been beaches, unnoticed by most of the people who walk across them. Now let me tell you about something that sound does in the ocean that seems almost magical. Acoustic daylight. In the ocean, sound can travel for hundreds or thousands of miles. And because there's always ambient noise, always something making sound somewhere, the ocean is never truly acoustically silent. There's always a background hum, a combination of waves, rain, biological sounds, distant shipping, all blending together. Some researchers have proposed using this ambient noise as a kind of illumination. Just as we see objects because they reflect light, we could theoretically see objects in the ocean by how they reflect or scatter the constant background sound. This concept is called acoustic daylight imaging. It hasn't been perfected yet, but the principle is sound. The ocean is bathed in acoustic energy, and objects in that ocean create acoustic shadows and reflections. With the right sensors and processing, you could theoretically create images from sound alone, seeing the ocean not with sonar pings, but with a natural soundscape. But here's what makes it profound. If we can detect objects by the sound they scatter, then every object in the ocean is constantly being illuminated by the ambient noise. Everything is reflecting sound constantly, creating an acoustic signature that spreads through the water. In a way, nothing in the ocean is truly hidden. Everything is announcing its presence acoustically, reflecting the constant wash of sound that fills the water. We just haven't developed the sensors and the processing to see those reflections clearly yet. The ocean is full of acoustic light, and everything in it is visible in that light, if only we knew how to look. Let me tell you about something found near hydrothermal vents that challenges our understanding of how complex life can be: the Pompeii worm. These worms live directly in the walls of hydrothermal vent chimneys, in one of the most extreme environments on Earth. The tail end of their burrow can be exposed to temperatures around 176 degrees Fahrenheit, while their head pokes out into water that might be 60 degrees or less. This means a single organism is experiencing a temperature gradient of over 100 degrees across its body length. No other known animal tolerates such extreme temperature variation across its body. They've essentially evolved to live in an environment that would instantly kill most other organisms. But here's what's strange. They don't do it alone. The worms are covered in a fleece-like layer of bacteria that may help insulate them from the heat. The bacteria might also detoxify some of the chemicals in the vent fluid. It's a symbiotic relationship, the worms providing a habitat for bacteria, the bacteria providing protection for the worms. And these worms grow fast, reaching full size in just a few years, then dying and being replaced by new worms. The population turns over quickly, generations succeeding one another in the hostile environment of the vent. When the vent stops flowing, the entire ecosystem dies. The worms, the bacteria, everything dependent on the heat and chemicals from below, all of it collapses within weeks. And if the vent starts flowing again later, it must be recolonized from other vents, larvae drifting through the cold, deep ocean, somehow finding the new or reactivated vent and establishing a new population. Life at the vents exists on a knife edge, thriving in extreme conditions, but completely dependent on the geological activity that creates those conditions. When the geology changes, entire ecosystems vanish and must be rebuilt from scratch. Now let me tell you about sargassum, a floating seaweed that creates entire ecosystems in the open ocean. Sargassum is unique among seaweeds in that it can complete its entire life cycle while floating, never attaching to the bottom. It forms vast mats in certain areas of the Atlantic, particularly the Sargasso Sea, where the circular currents trap it and allow it to accumulate. These floating mats become habitats for hundreds of species. Fish, shrimp, crabs, even sea turtles use the sargassum as shelter and feeding grounds. Some species are found almost exclusively in sargassum mats, having evolved specifically for this floating habitat. But here's what's changing. The amount of sargassum in the Atlantic has increased dramatically in recent years. Massive blooms now form regularly, sometimes washing ashore on Caribbean beaches in such quantities that they rot and create toxic conditions. In 2018, a sargassum bloom in the Atlantic was estimated to weigh over 20 million tons. Why this is happening remains unclear. It might be related to nutrient runoff from land, climate change, or changes in ocean circulation. But the result is that what was once a unique and specialized habitat is now becoming overwhelming, creating too much of something that was previously in balance. The floating gardens of the Atlantic are expanding beyond their traditional boundaries, and what was once a unique ecosystem is becoming a problem, demonstrating how even natural phenomena can become disruptive when they occur at scales beyond what the system evolved to handle. The ocean's balance is delicate, and even increases in natural features can create new problems when those increases are rapid enough and large enough to overwhelm existing patterns. Let me tell you about something found on the ocean floor that tells a story about human conflict. Munitions dumps. After both world wars, nations disposed of excess munitions by dumping them in the ocean. Bombs, shells, chemical weapons, all of it was loaded onto ships or barges, taken out to sea, and dumped overboard. The ocean was treated as a convenient disposal site for weapons that were too dangerous to keep and too expensive to properly destroy. These munitions are still there, thousands of tons of explosives and chemical weapons resting on the ocean floor, slowly corroding. Some are in deep water, some in relatively shallow coastal areas. Many are in areas that are now popular for fishing, drilling, or other activities, and they're becoming unstable. The casings are corroding after decades in salt water. Some chemical weapons are leaking, releasing toxins into the sediment and water. Fishermen occasionally drag up old munitions in their nets. Construction projects sometimes encounter them during dredging or cable laying. But here's what's concerning. We don't have complete records of where everything was dumped. Some dumping was poorly documented or not documented at all. There are probably thousands of munitions on the ocean floor that we've lost track of. Forgotten legacy of past wars sitting in the sediment, slowly degrading. The ocean has been holding these weapons for us, containing them for decades, but it won't contain them forever. Eventually, the ocean will release what we put into it. The casings will fail completely, and the contents will disperse into the environment. We use the ocean as a hiding place for problems we didn't want to deal with, assuming they would stay hidden forever. But the ocean keeps nothing forever. It only holds things temporarily before returning them, changed to the surface world. Now let me tell you about jellyfish, but consider them not as simple drifters, but as one of the ocean's most successful predators. Jellyfish have existed for over 500 million years, making them one of the oldest animal groups still in existence. They've survived every mass extinction, every climate change, every ecological disruption, thriving in ways that more complex organisms could not. And they're increasing. In many parts of the ocean, jellyfish populations are exploding, creating massive blooms that can be hundreds of miles across. These blooms overwhelm local ecosystems, consuming vast amounts of plankton and fish larvae, sometimes collapsing fisheries. But here's what makes them effective. They're nearly invisible. Their bodies are over 95% water, making them difficult to see in the water. Their tentacles trail behind them, often extending for feet or even yards, creating a nearly invisible net of stinging cells. And they're efficient. They require very little energy to survive, drifting with currents, capturing whatever contacts their tentacles. In degraded ecosystems, where fish populations are reduced and plankton blooms are common, jellyfish often thrive, filling the niche that fish once occupied. Some researchers believe we're creating a world more favourable to jellyfish, warmer water, which they tolerate well, reduced competition from overfished species, increased nutrients leading to more plankton for them to eat. We might be accidentally transforming the ocean toward a state that existed millions of years ago, when jellyfish were more dominant. The ancient forms are returning, not through evolution, but through us removing the things that competed with them. The ocean is being simplified, and the beneficiaries are some of its oldest, simplest, most persistent inhabitants. Our next tale is about something that happens to whales when they're old and ready to die. They dive one last time. Whales are conscious breathers. They must choose to surface to breathe. When they're injured or sick, they sometimes continue swimming toward the surface through sheer will, fighting to breathe even when their bodies are failing. But eventually, if they survive long enough to grow truly old, there comes a moment when they stop fighting. They take a final breath and dive, swimming down into the depths, going deeper than they've gone in years, perhaps deeper than they've ever been. And they don't come back up. They descend until they no longer can, until their bodies give out or their lungs empty, and then they continue sinking, becoming a whale fall, joining the cycle we discussed earlier. Researchers studying whale populations sometimes notice when mature individuals disappear. They track these whales for years, sometimes decades, and then one day, the whale simply isn't seen again. No body washes ashore, no signs of distress are noted. The whale just stops appearing. Where did they go? Down, into the deep, making a final journey into the darkness, perhaps driven by instinct, perhaps by a choice we can't understand, returning to the depths that sustained them throughout their lives, becoming food for the ecosystem of the deep sea floor. The ocean calls its largest children home in the end, and they answer, diving down one last time, leaving the surface world of air and light for the deep world of pressure and darkness, completing a cycle that has played out for millions of years, as long as whales have swum in the sea. Rest now as the whales rest, descending peacefully into the deep, letting the darkness hold you, settling into the quiet, where all struggles cease and the ocean's patience becomes your own. As we continue our journey through maritime mysteries, let me tell you about lighthouse keepers and the peculiar isolation they experienced. Before automation, lighthouse keepers lived alone or in small groups on remote rocks and islands, sometimes for months at a time. Their job was to keep the light burning, warning ships away from dangers they themselves were stationed upon. These keepers reported strange psychological effects from their isolation. Time seemed to move differently. Some reported losing track of days, despite keeping careful logs. Others described vivid dreams that felt more real than waking life. Many reported seeing things, ships that weren't there, lights in the fog, figures on the rocks. But here's what's haunting. Some lighthouses were simply abandoned by their keepers, the light still burning, meals left half-eaten on the table, no sign of struggle or departure. The most famous case is the Flannan Isles Lighthouse in Scotland, where 3 keepers vanished in 1900, leaving behind only a series of increasingly disturbed log entries. The ocean isolates, and that isolation does things to the human mind. The keepers stood at the boundary between land and sea, watching the ocean day after day, year after year, and sometimes that watching changed them in ways that can't be easily explained. The automated lights still flash their warnings, but they do it without witness now, without the lonely human observers who once kept vigil in the darkness, watching the ocean watch them back. Now let me tell you about something that exists in polar waters that seems to pause time itself: anchor ice. In extremely cold conditions, ice can form not at the surface, but on the seafloor, a phenomenon called anchor ice. It forms when water is supercooled, below freezing temperature but still liquid, and then contacts a surface where it can crystallize. This ice grows upward from the bottom, slowly engulfing everything it touches. Bottom-dwelling creatures can become frozen in place, trapped in ice that's growing from below. Plants become encased. Rocks develop coatings of ice that make them look like strange sculptures. Divers who've witnessed anchor ice forming describe it as surreal, watching ice grow upward through the water column, defying the normal expectation that ice forms at the surface and sinks. The world is being frozen from the bottom up, and everything caught in the process becomes suspended in crystalline time. When the anchor ice eventually releases, either from warming or from buoyancy lifting entire chunks to the surface, it brings with it whatever it captured: shells, organisms, sediment, all frozen together in blocks of ice that float to the surface carrying samples of the seafloor. The ocean can freeze in ways that seem to violate the normal rules, and in doing so, it creates temporary monuments, ice sculptures that capture the bottom and display it briefly at the surface before melting and releasing what they held. Let me tell you about something discovered relatively recently that changes how we understand ocean memory. Water masses retain their properties for decades as they flow through the ocean. When water sinks in the polar regions, it carries with it the temperature, salinity, and chemical signature of that place and time. As it flows through the deep ocean along well-defined pathways, it maintains those properties for years, decades, even centuries. Scientists can identify water masses by their characteristics and track them through the ocean. They can tell you that this particular water was last at the surface in the North Atlantic 80 years ago and has been flowing southward through the deep ever since. This means the ocean has a memory written in the water itself. Past conditions, past temperatures, past chemistry, all preserved in water masses flowing through the depths. The ocean doesn't just respond to current conditions. It carries the past within it, mixing it slowly with the present. And here's what's profound. This means changes we make to the ocean today won't fully manifest for decades or centuries. The water sinking now carries today's temperature signature, but it will take 100 years to complete its circuit through the deep ocean. The full consequences of our warming will emerge slowly as the water that's sinking today eventually returns to the surface, carrying its memory of our era. The ocean is patient and remembers everything, writing our changes in water that flows too slowly for us to perceive, creating consequences that will emerge long after we're gone. Now, let me tell you about something that happens in the ocean every night that creates one of nature's most spectacular displays. Bioluminescent bay phenomenon. In certain sheltered bays, with the right conditions, populations of bioluminescent dinoflagellates can become so dense that any movement in the water creates cascading waves of blue-green light. Swimming through these bays is like swimming through liquid starlight, every motion leaving trails of luminescence. The most famous of these bays are in Puerto Rico, Jamaica, and the Maldives, but there are others scattered around tropical and subtropical coasts. In these bays, the combination of nutrients, protection from waves, and temperature creates perfect conditions for the dinoflagellates to thrive in extraordinary numbers. But here's what's fragile about them. These bays require precise conditions to maintain their bioluminescence. Pollution, development, even increased boat traffic can disrupt the populations. Several once spectacular bioluminescent bays have lost their glow due to human activity in their watersheds. When they fade quickly. The dinoflagellates are still there, just not in the numbers needed to create the spectacular display. The light goes out, and what was once magical becomes ordinary. Another bay like any other, the bioluminescence reduced to occasional sparks rather than cascading illumination. These are places where the ocean's beauty becomes visible, where the invisible world of plankton makes itself known through light. And they're disappearing, one by one, as the conditions that create them become rarer. Let me tell you about sperm whales and what they do that seems almost impossible. They dive to depths over 6,000 feet, holding their breath for 90 minutes or more, hunting in darkness and pressure that would crush most creatures. Sperm whales are the deepest diving mammals, regularly descending to depths where the pressure is over 170 atmospheres. At these depths, their lungs collapse completely, their rib cages compress, their bodies undergo transformations that allow them to withstand pressure that would kill other mammals. But here's what's remarkable. They're hunting down there. They're chasing giant squid and other deep-sea prey through the darkness, using echolocation to navigate and find food. They're engaging in active predation at depths where humans can only survive in specially designed vehicles. And they do this repeatedly, diving and surfacing multiple times a day, their bodies transitioning between surface pressure and extreme depth pressure over and over. The physiological adaptations required for this are extraordinary. Special proteins that remain functional under pressure, blood that can store enormous amounts of oxygen, muscles that can function with minimal oxygen for extended periods. When they surface after these dives, they must breathe heavily for several minutes, repaying the oxygen debt their bodies accumulated during the dive. But then they dive again, returning to the depths, resuming the hunt in the darkness and pressure. They're adapted for a world that exists at the very limit of where mammals can survive, and they thrive there, hunting and living in conditions that seem impossible for warm-blooded, air-breathing creatures. The ocean's depths are their hunting grounds, and they navigate them with a confidence born of millions of years of evolution. Now let me tell you about something that certain deep-sea fish do that seems almost like theft. They eat bioluminescent prey, and then use that bioluminescence for themselves. Some deep-sea fish feed on bioluminescent organisms, usually crustaceans or jellyfish that produce their own light. Instead of digesting these organisms completely, the fish retain the bioluminescent compounds, or even the light-producing bacteria, incorporating them into their own bodies. These fish essentially steal the ability to produce light, using organs called photophores that are filled with bioluminescent material taken from their prey. They might use this stolen light as camouflage, matching the downwelling light from above to hide their silhouette from predators below. Or they might use it as a lure, attracting curious prey with stolen luminescence. But here's what's strange. The fish must constantly replenish this light by eating more bioluminescent prey. If they stop eating these organisms, their light fades. They're dependent on their prey not just for nutrition, but for the ability to produce light. It's biological piracy, creatures stealing from others the ability to glow, maintaining that ability only as long as they keep consuming the organisms they took it from. The deep ocean creates these strange dependencies, these relationships where one creature's ability becomes another's tool, borrowed or stolen for as long as the relationship continues. Let me tell you about something found occasionally drifting in the ocean that seems impossible. Pumice stones with trees growing from them. Sometimes when volcanic eruptions produce pumice rafts, seeds or plant fragments get caught in the floating stone. If conditions are right, if the pumice floats long enough and rain provides fresh water, these seeds can germinate. Trees begin growing from the floating stones, creating impossible gardens drifting on the ocean. These floating islands of stone and vegetation can drift for months or years, the plants growing from pumice that has no soil, sustained by rainwater and air, floating through the ocean like impossible dreams of land. Eventually, the pumice becomes waterlogged and sinks, carrying the plants down with it. Or sometimes the raft breaks up in storms, scattering the stones and plants across the ocean. Very rarely, these rafts might make landfall, delivering their cargo of stone and seeds to beaches or shores where they wouldn't otherwise arrive. But here's what's profound. This is how islands get colonized. When new volcanic islands emerge from the ocean, plants don't just appear. They arrive on rafts, drifting debris, carried by birds, distributed by the ocean's currents. These pumice rafts with their impossible gardens might be one mechanism by which the ocean distributes life, carrying seeds and plants across distances they could never cross otherwise. The ocean creates temporary lands that drift and disperse, carrying passengers who might someday found new populations on distant shores if they survive the journey. Now let me tell you about sharks, but consider them as what they truly are: the ocean's success story, largely unchanged for over 400 million years. Sharks existed before trees, before flowers, before most forms of life we recognize today. They survived the mass extinction that killed the dinosaurs, the ice ages, the dramatic shifts in ocean chemistry and temperature. They persisted through it all, adapting but never fundamentally changing. They're cartilaginous fish, meaning their skeletons are made of cartilage rather than bone, which makes them lighter and more flexible. They must keep swimming to breathe, water moving over their gills as they move through the ocean. They're perfectly adapted to their role as apex predators. But here's what's tragic. After surviving for 400 million years, sharks are now declining rapidly due to human activity. Overfishing, particularly for shark fins, has reduced many shark populations by 90% or more in just the last few decades. The ocean's oldest successful design, a body plan that has worked for longer than almost any other, is being eliminated in a geological instant. Creatures that survived asteroid impacts and mass extinctions are being removed from the ocean by fishing nets and long lines. The ocean kept sharks alive for hundreds of millions of years, preserving them through every catastrophe Earth experienced. But it can't protect them from systematic hunting, from targeted removal at a scale and efficiency the ocean has never encountered before. Let me tell you about something that's been found in the ocean that represents humanity's oldest tradition of ocean communication: messages in bottles. For centuries, people have thrown bottles with messages into the ocean, either as experiments in ocean currents, as distress signals, or simply as messages to unknown recipients. Some of these bottles have travelled for decades, circling ocean gyres, before washing ashore thousands of miles from where they entered the water. The oldest confirmed message in a bottle was found in 2018, having been thrown into the ocean in 1886. It had drifted for 132 years before being found on a beach in Australia. The paper inside still legible, despite more than a century in the sealed bottle. But here's what's haunting about these bottles. They represent hope, cast into an indifferent medium. The people who threw them rarely expected a response. They were sending messages into the unknown, trusting the ocean to carry them, perhaps to someone, perhaps to no one. And the ocean does carry them, faithfully, for years or decades or centuries, until eventually they wash ashore or sink or break apart. The messages are often simple: a name, a date, a location. Sometimes a plea for rescue, sometimes just a hello to whoever finds this. They're tiny acts of communication across time and distance, people reaching out through the ocean to touch someone they'll never meet, in a time they'll never see. And the ocean facilitates this, carrying these bottled messages through its currents, patient and thorough, eventually delivering them or keeping them forever, depending on the whims of wind and current. Now let me tell you about something happening at the ice-ocean boundary that's accelerating faster than scientists predicted. Ice shelf collapse. Ice shelves are floating platforms of ice extending from land-based glaciers into the ocean. They're important because they buttress the glaciers behind them, slowing the flow of ice from land into the sea. When ice shelves collapse, the glaciers behind them accelerate, flowing faster into the ocean, and they're collapsing. The Larsen B ice shelf in Antarctica, which had been stable for thousands of years, collapsed over just a few weeks in 2002. Other ice shelves are thinning, developing cracks, showing signs of instability. The mechanism is insidious. Warmer ocean water circulates beneath the ice shelves, melting them from below. The surface looks stable, but underneath, the ice is thinning, weakening, until suddenly it fails catastrophically. But here's what's concerning. Once an ice shelf is gone, it doesn't reform easily. The ocean has access to the glacier front, melting it directly, and the glacier flows faster, delivering more ice to the ocean. It's a self-reinforcing process. Ice shelf collapse leads to faster glacier flow, which delivers more ice to the ocean, which raises sea level, which potentially allows warmer water to access more ice shelves. The boundary between ice and ocean is dissolving faster than the ice can be replaced, and once that boundary fails, there's no easy way to restore it. The ocean is patient, but when it claims ice, it claims it permanently, converting solid to liquid, raising its own level, gradually drowning the coasts. Let me tell you about something that happens on certain beaches that creates an eerie sound. Singing sands. On some beaches, under specific conditions, the sand produces a sound when you walk on it or when wind moves across it. The sound can range from a low hum to a loud roar, depending on the beach and conditions. It's caused by the friction between sand grains of very specific size and shape, producing vibrations that resonate through the beach. The phenomenon is rare and requires precise conditions. The sand must be a specific grain size, very clean and very dry. Only a few dozen beaches worldwide produce this effect consistently, and many more produce it occasionally under perfect conditions. Ancient civilizations were aware of singing sands and sometimes considered them sacred or haunted. Marco Polo described hearing strange music from desert sands. Sailors reported beaches that hummed or moaned when they walked on them. But here's what's strange. We still don't completely understand why some beaches sing and others don't. The conditions can be measured, the phenomenon can be reproduced in laboratories, but the exact mechanism by which sand grains produce such organized sound remains debated. The ocean creates beaches that sing, that produce organized sound from the random collision of countless grains. It's order emerging from chaos, music from friction, the beach announcing itself through vibrations that carry through the air like an ancient voice. Now let me tell you about what exists at the absolute deepest point in the ocean. The Challenger, deep in the Mariana Trench, nearly 7 miles below the surface. Only a handful of people have ever been there. The pressure at that depth is over 16,000 pounds per square inch, over 1,000 times atmospheric pressure at sea level. The water temperature is just above freezing. No light has ever reached there naturally. And yet, life exists. When James Cameron descended to the Challenger Deep in 2012, he saw amphipods, shrimp-like creatures, swimming past his viewport. Small fish, sea cucumbers, bacteria, all living at the absolute limit of where complex life can exist on Earth. But here's what's disturbing. He also saw plastic. At the deepest point in the ocean, in a place only visited by humans a handful of times, plastic waste has already arrived. The ocean's deepest point has been touched by human pollution before most of it has been touched by human exploration. The Challenger Deep represents the ocean's ultimate mystery and its ultimate vulnerability. It's the most remote place on Earth's surface, harder to reach than the moon in some ways, and we've managed to pollute it before we've managed to properly explore it. The deepest blue is not untouched wilderness. It's already carrying traces of human activity, already absorbing our waste, already showing signs of a transformation we've initiated but can't control. Let me tell you about something happening right now. Inhabited islands disappearing beneath the waves. Low-lying island nations in the Pacific and Indian Oceans are facing the reality of rising seas. Some islands have already been abandoned as saltwater intrudes into freshwater supplies and storm surges overtop the land with increasing frequency. The residents of these islands are becoming climate refugees, forced to leave homes their families have occupied for generations, perhaps for thousands of years. These aren't temporary evacuations, they're permanent relocations. The islands will be submerged, and the communities that lived on them will cease to exist as geographic entities. But here's what's profound. These islands aren't sinking. The ocean is rising. The land is the same elevation it's always been, but the sea level relative to that land is increasing, gradually drowning places that were once secure. And it's not just remote Pacific atolls. Major cities are facing increasing flooding. Miami, New Orleans, Venice, Bangkok, Jakarta. The list of places threatened by rising seas includes some of the world's largest and most important urban centres. The ocean is slowly reclaiming coasts, not through dramatic storms, but through incremental rises, millimetres per year that add up to centimetres per decade, eventually amounting to feet of rise that render coastal areas uninhabitable. The map of the world is changing as the ocean expands, and that change is accelerating, creating refugees and abandoning infrastructure, rewriting geography at a pace we can measure in single lifetimes. Now let me tell you about something installed on the ocean floor that has been recording continuously for decades: deep ocean hydrophones. These underwater microphones were originally placed to detect submarine activity during the Cold War, but they've been recording everything: whale calls, geological activity, ship traffic, storms, ice breaking. Every sound the ocean makes has been captured by these listening stations. The archive they've created is extraordinary. Researchers can go back decades and listen to how the ocean sounded in the past, comparing it to how it sounds now. And what they've found is disturbing. The ocean is getting louder. Ship traffic has increased dramatically. Seismic surveys for oil and gas add explosive sounds. Naval sonar exercises contribute. Even the sound of ice melting creates noise as it fractures and shifts. The baseline ambient noise level in much of the ocean has increased significantly since the hydrophones began recording. But here's what this means for marine life. Many species depend on sound for communication, navigation, finding mates, detecting prey or predators. As the ocean gets louder with human-made noise, the distance over which animals can communicate effectively is shrinking. A whale that could once communicate with others hundreds of miles away might now only be heard for a fraction of that distance. The ocean is filling with noise, and that noise is drowning out the natural soundscape that marine life evolved in. We're not just polluting the water, we're polluting the acoustic environment, making the ocean a louder, more chaotic place for creatures that depend on sound to survive. Let me tell you about something found occasionally in icebergs that provides a window into the distant past. Air bubbles trapped in ice that fell as snow thousands of years ago. When snow falls on Antarctica or Greenland, it gradually compresses into ice, trapping air bubbles in the process. These bubbles contain samples of the ancient atmosphere, perfectly preserved in ice that slowly flows toward the sea. When an iceberg carves off a glacier and begins its journey through the ocean, it carries these bubbles with it. If the ice melts or breaks apart, the ancient air is released, escaping into the modern atmosphere after being trapped for millennia. Scientists studying ice cores have found air bubbles that are hundreds of thousands of years old, containing samples of Earth's atmosphere from before humans existed. The bubbles reveal past carbon dioxide concentrations, past temperatures, past atmospheric conditions. But here's what's poignant. As glaciers retreat and ice shelves collapse, all that preserved history is being released prematurely. The ancient ice is melting into the ocean, the bubbles are escaping, and the archive they represent is being destroyed before we've finished reading it. The ocean is accepting this meltwater and its cargo of ancient air, mixing it into the present, erasing the boundary between past and current atmospheres, turning memory into current reality as the ice that preserved that memory dissolves. Now let me tell you about something that exists in the deepest parts of the ocean that we've barely begun to explore. Abyssal storm systems. In the deep ocean, slow but powerful currents occasionally accelerate, creating what oceanographers call abyssal storms. These aren't surface storms with wind and waves. They're deep water events where currents suddenly intensify, stirring up sediment from the ocean floor and creating turbulent conditions in the usually calm depths. These storms can last for weeks or months, transporting sediment across vast distances, reshaping the ocean floor, disturbing ecosystems that normally experience very stable conditions. They're driven by complex interactions between different water masses, by eddies descending from the surface, by tidal forces acting on deep water. But here's what's remarkable. We know they exist primarily from instruments deployed on the seafloor that record sudden increases in current speed and sediment suspension. We've never directly observed an abyssal storm in progress. They happen in darkness, thousands of feet down, invisible from the surface. The deep ocean has its own weather, its own storms, its own patterns of chaos and calm, all occurring in a realm we've barely visited and certainly don't monitor regularly. The abyss is dynamic, changing, sometimes violent in its own slow way, and most of the time we're completely unaware of what's happening down there. Let me tell you about a phenomenon that occurs in certain coastal waters that creates one of the ocean's most ethereal displays: blue tears, or what scientists call bioluminescent algae blooms. In specific conditions, bioluminescent plankton bloom in such density that every wave breaking on the beach produces cascades of blue light. The shore glows blue with each wave, the foam sparkles, even footprints in the wet sand create luminescent impressions. This phenomenon is most famous along certain coasts in China and Taiwan, but it occurs elsewhere as well. When conditions are right, entire coastlines can glow blue at night, creating scenes that look almost alien, as if the ocean is electrically charged. But here's what's bittersweet. Like other bioluminescent phenomena, blue tears are fragile. They require specific conditions, and those conditions are increasingly disrupted by pollution, coastal development, and climate change. And when they occur, they're fleeting. A bloom might last only a few days or weeks before conditions change, and the plankton disperse or die off. People travel long distances for a chance to see blue tears, but there's no guarantee they'll occur, even in places where they're relatively common. The ocean creates these brief windows of extraordinary beauty, moments when invisible processes become visible light, when the microscopic becomes magnificent. And then the window closes, the light fades, and the ocean returns to darkness, keeping its beauty hidden again. Now let me tell you about something that exists on the ocean floor in staggering quantities, but will probably never be recovered. Treasure from shipwrecks. Estimates suggest there might be up to 3 million shipwrecks on the ocean floor, many of them carrying valuable cargo when they sank. Gold, silver, gems, artifacts, all of it resting in the deep, protected by depth, location, and the sheer difficulty of recovery. The most famous treasure ships are known and have been targets of salvage operations for decades. But for every known treasure wreck, there are hundreds or thousands that are lost in every sense. Their location unknown, their cargo undocumented, their very existence sometimes uncertain. The ocean is holding wealth that will never be recovered, treasure that has passed out of human reach and into a realm where it serves no purpose except perhaps as habitat for marine life that colonizes the wreckage. Gold coins become homes for barnacles, silver bars become covered in coral. But here's what's profound. The monetary value is meaningless in the deep. The ocean doesn't care about treasure, doesn't recognize the value humans placed on these materials. It treats gold the same as any other metal, allowing it to corrode or become encrusted, incorporating it into the reef-like structures that grow on wrecks. The treasure is still there, will probably always be there, but it exists now in a context where its value is measured not in currency, but in habitat, not in what it can buy, but in what it can support, in the deep ocean's economy of survival. Let me tell you about something fundamental that the ocean does, which makes all life on Earth possible: the thermohaline circulation, the global conveyor belt of ocean currents. This circulation is driven by temperature and salinity differences. Cold, salty water sinks in the polar regions and flows along the ocean floor toward the equator. Warm surface water flows toward the poles to replace it. This circulation connects all the world's oceans in a single system that takes about 1,000 years to complete one full circuit. This conveyor belt transports heat from the equator to the poles, moderating climate globally. It brings nutrients from the deep to the surface, supporting marine ecosystems. It distributes oxygen to the deep ocean. It's one of the planet's fundamental processes, as important as weather systems or plate tectonics in shaping Earth's environment. But here's what's concerning. There's evidence this circulation is slowing down. As polar ice melts, it adds fresh water to the oceans, reducing salinity. This makes the water less dense, less likely to sink, potentially weakening the circulation. If the thermohaline circulation weakens significantly or stops, the consequences would be dramatic. Europe would cool, tropical regions might warm even more rapidly, ocean oxygen levels could drop, marine ecosystems would shift dramatically. The system that has regulated global climate for millions of years might be changing in ways we can't fully predict. The ocean's eternal cycle might not be eternal after all, just very long-lived, and we might be witnessing the beginning of a transformation that won't be complete for centuries, but has already begun. Our final story is not about something strange or unsettling, but about something simple and profound. The ocean continues. Despite everything we've discussed, the pollution and the warming and the changes, the ocean continues its fundamental work. Waves continue to break on shores. Tides continue their eternal rhythm. Currents continue to flow. Life continues to adapt and persist in even the most altered environments. The ocean is resilient in ways that are difficult to comprehend. It has survived asteroid impacts, volcanic episodes that darkened the sky for years, ice ages and periods of extreme heat, massive extinction events that eliminated most marine species. And it recovered, life returning, diversity rebuilding, the ecosystem finding new balances. This isn't to say that what we're doing doesn't matter. It does, profoundly. But the ocean's story is longer than our story, began before we existed, and will continue after we're gone. The ocean measures time in scales we can barely imagine, recovers from disasters over periods we consider geological rather than historical. The ocean is patient. It absorbs our impacts, slowly incorporating our changes into its vast system. It will adapt, even if that adaptation takes thousands or millions of years. Life will continue in some form, finding new niches, evolving new solutions, filling the spaces we leave empty. This is both comforting and sobering. The ocean will continue, but the ocean we know, the ocean that supported human civilization, that fed us and transported us and shaped our cultures, that specific ocean might change into something different, something we wouldn't recognize. But through it all, the fundamental ocean remains. Vast, deep, powerful, patient, enduring. It breathes with the rhythm of life and death, absorbs the light of day and the darkness of night, rises and falls with the tides, always moving, always changing, always present. Rest now, knowing that the ocean continues its work. Let the rhythm of the waves carry you into deep sleep. Let the vastness of the sea dissolve your worries. Let the eternal patience of the deep teach you peace. The ocean has witnessed everything and will witness everything to come, constant in its inconstancy, eternal in its changes, always the ocean, always home to mysteries and wonders beyond counting. Sleep well, carried on gentle tides toward morning, held by water that has held life since life began, rocked by waves that have been breaking on shores since shores existed, soothed by the eternal voice of the sea.